Okay. Good morning, everyone, and thank you so much for being able to join us again for day 2 of the 2023 Animas and San Juan Watersheds Conference. Most of you probably know me by now, but for those who may be joining us just today, either here at San Juan College or virtually via Zoom, my name is Mark Sheely. I'm a program specialist with the New Mexico Water Resources Research Institute, and on behalf of the Institute, the planning committee for this conference, it's a pleasure to have you all here today. I'm excited to get to our half day of oral presentations, as well as some of the afternoon activities that we have planned out in the field and here in the meeting room as well. We'll be hearing this morning presentations on efforts related to the WIN Act from Kate Sullivan of the EPA and Shelley Lemon of the New Mexico Environment Department, as well as innovative technologies that are being applied to help facilitate water justice for tribal communities from Ronaldo Sosi of New Mexico Tech. Later this morning, after our break, just to let you know, we'll be rearranging the room a bit for a special morning session for our acequia drought challenges and collaborative strategies for resilience in the San Juan Basin. And this will also be related to the afternoon session that we have planned, a gathering of acequia leaders and collaborators, and to help explain a little bit more about that for those of you who might be interested and wanting to learn a little bit more about the session later today or this afternoon, I'd like to welcome Connie Maxwell, a postdoctoral researcher at the Water Resources Research Institute.
Thank you, Mark. Good morning, everybody. Just a couple of words, but as Mark mentioned, at 10:30, we'll be having a session where we're going over some of the efforts that us at the Water Institute have been working on with the New Mexico Acequia Association in different regions. And one of those projects includes Kevin Lombard from the Agricultural Research Station here in Farmington. And so we'll be talking about different strategies for mitigating the really significant drought challenges that we have in many regions of the state, but specific to this region. There will be 4 acequia leaders that will be on a panel. We'll do a little presentation to start in terms of what the projects are. And then after that session, we're going to continue the conversation. We'll have lunch. And as lunch winds down, we'll try to catch it kind of as soon as possible because we know folks don't necessarily have a whole lot of time. So as soon as lunch starts to wind down, we'll convene into a planning session where we'll talk very specifically about next steps in terms of those projects. So we're thinking, 12:45 for about an hour. We're going to try to keep it to an hour. We won't shut the conversation down, but just to give you guys a sense in terms of timing, if you want to join that session, that's really going to be the plan. All right, so that's it, unless anybody has any questions.
Thanks so much, Connie. Also, after lunch today, those of you who have signed up for our field trip to visit some of the Lower Animas watershed-based plan implementation project sites that's being hosted by the San Juan Soil and Water Conservation District as well as the New Mexico Environment Department. For those of you who have registered or who are on the wait list, in case we have some no-shows, we'll be meeting at in front of the registration kind of check-in desk to make sure anyone who's there that's going to come, we can kind of get an accurate count, and then we'll make our way out, probably where most of you came in front of the bookstore, where our transportation will be waiting for us to take everyone to see the field trip sites. So if you're curious, like, am I registered for the field trip, or I'm on the waiting list, or I'd like to be on the wait list, you can check in with our staff at the front desk out there, and they'll let you know your status. Okay, well, to start off, our program, I'd like to welcome Kate Sullivan of the U.S. Environmental Protection Agency. She's a senior researcher at the EPA's Office of Research and Development in Athens, Georgia. She was the project lead and lead author of EPA's scientific investigation of the impacts of the Gold King mine release on the Animas and San Juan rivers, published in 2016. She has continued her scientific interest in better understanding how these rivers function and has supported the San Juan Watersheds monitoring program since 2018. Her scientific background is in hydrology and geomorphology. Thank you so much, Kate, and let me pull up your slides. Oh, here's our clicker, and then there's the laser pointer.
Okay. Thank you for having me. I've been working on the watershed now for ever since just about the day Gold King happened, so I've really enjoyed working here. Today I'm going to share with you some of the results from the monitoring project that's been conducted under the WIN program. But first I'm going to familiarize you a little bit with the WIN program and what's happening there. WIN is from the Watershed Infrastructure Improvement for the Nation Act, and Congress allocated funding to this watershed after Gold King of tune of $20 million to be spent by the jurisdictions, the states and the tribes that were affected by the spill. They had a number of scientific questions besides many of the management issues and the local concerns, but what's the status of water quality conditions in the watershed? Where do materials originate? Really asking the basic questions of how this watershed functions, where materials end up. All those questions were very paramount. Risk assessment, et cetera, as part of the Gold King really brought it to mind. But these issues have been here for a long time. The projects were designed by the Colorado Department of Public Health, New Mexico Department of Environment, representing your locations, Utah Department of Environmental Quality, Navajo Nation, Southern Ute Tribe, and the Mountain Ute Tribe. Before I talk too much, so the money was spent on a variety of different projects, one of which was a monitoring program that EPA basically administered. I'll talk about that in a second, but I wanted to introduce the watershed a little bit. We've had a number of talks that talked about various aspects of it, but the San Juan, here's a map of the San Juan watershed and its tributaries. There are really about 8 major tributaries, of which the Animas is the largest perennial stream in the watershed today. The building of the Navajo Dam in the 1960s basically isolated the upper headwaters from water quality in the San Juan River, so it's really kind of no longer assessed, but that's where a lot of water comes from, but it's not really playing in a water quality perspective. Really, the Animas is the largest river that's affecting water quality through, obviously, in the Animas, but also in the San Juan. Other tributaries, there's several northern tributaries. What I call the northern tributaries, the Mancos, McElmo Creek, Cottonwood Wash didn't make this map. And there's 2 major southern tributaries, the Chaco River and Chinle Creek. On a hydrology viewpoint, on an annual basis, really the upper Animas and the San Juan Navajo Dam are really the primary producers of water for this entire river system. Most of the rivers that's primarily due to your climate and the geographic, physiographic regions here. But you have 2 basic climate regions. You have snowmelt coming from the San Juan Mountain headwaters on a very predictable flow pattern that lasts about 3 months a year. You're all very familiar with it. And then you have a monsoonal storm kind of production of water in these very episodic, short, rapid flow spikes that occur throughout the watershed. They generally do not produce very much water, although I'm showing you here a record where I've superimposed Animas at Durango versus Chinle Creek. Notice that the Chinle Creek is from the scale on the right, and it's 10 times, I've had to increase it 10 times to make it even show up. But there's very different flow regimes, and these create very different introduction of water quality parameters. And I'm today going to talk virtually exclusively about metals, which has been one of the big issues for a very long time in this watershed. So you have very different delivery mechanisms, and largely, but you can't really emphasize the importance enough of the Animas on producing water for the entire region. So to capture that, the water quality monitoring, part of the WIN funding went to water quality monitoring, distributed it throughout the watershed. So it begins kind of up there in the Silverton area. There was a couple sites up there. The sites that were selected were either long-term sites that some of the states or tribes had already been monitoring. Many of them were new that had started to be monitored after the Gold King event, there were many sites added during that time, and many of those were kept on as part of this monitoring program. So there's a total of 39 sites where water quality was collected in 10 sampling events. Now, this was largely administered by the EPA from 2018 to 2021, the first 5 years of funding. And that EPA basically hired contractors to do these sampling events, and they were planned, but where they were sampled and when they were sampled was planned by the states and tribe jurisdictions. And EPA just administered the contract. And then my involvement has been, I've been trying to process that data and learn what we can from that monitoring data. All that data is available. For the time frames you see here, the design was to try to capture peak flows from the snowmelt, and also to get base flow in between, both at the beginning, kind of in fall, and in the beginning of spring. And there was a notion we might be able to collect from some of these monsoonal events, but it's extremely difficult to plan that in advance. But we were fortunate to be able to capture one event here in March that was a regional storm event that taught us a lot about what happens in the flow regimes during storms in this system. So that's the data I've been working with. I am producing a report which will summarize. I don't really have time today to talk about many, many things that are available to learn from this data, but we will talk about those in the report, and those will all be available to you. But I want to hit some of the highlights here. So one, I just want to emphasize again the importance of the Animas River from a water quality perspective in the whole system. It's a significant contributor to flow on an annual basis. The Animas contributes anywhere from about half to sometimes as much as twice as much water as the Navajo Dam on an annual basis, depending on the snowmelt. So that year, this year is going to be one of those kind of years when it's going to contribute a great deal, a proportion of the annual load. But that extends right to a daily basis. This is a graph of the daily difference in flow down here in the Animas as it flows at Boyd Park versus the difference between it and the San Juan down here in Farmington. And basically, I've graphed up at the top the proportion of flow that the Animas contributes on a daily basis. For the length of record here, it's about 20 years. You can see it can range anywhere from very low, almost nothing, which happened in 2018 when you had a very low flows, all the way up to almost 100%. And on the average here, I've done the frequency of all of that. And on a daily basis, the Animas is contributing anywhere from about 30 to 80% of the water that you see. One of the really interesting things here is that it's the same number at Mexican Hat. There's almost no water added on a daily basis on average between the Animas and Mexican Hat. So that means, I emphasize that because from a water quality viewpoint, it means that the Animas has to be kind of important to the San Juan. In fact, after the Navajo Dam was built, I consider the Animas the headwaters of the San Juan. So the importance of the Animas has only grown over time. This is the records back to 1930, showing that it was pretty regular in the early part up to about 1960 when the Navajo Dam was built. It was anywhere from 30 to 60, but every year it's been increasing in how often the Animas is at least 70% of the flow. That's what I'm showing here, the number of days in that period. It used to be that the Animas really was a significant contributor up at the 70% level on a daily basis, mostly during the snowmelt, and that makes sense. And in fact, the dam has to be managed around what the Animas is able to produce every day. But that's increasingly occurring all year long and early time. So the Animas is real important. So again, the total numbers on a yearly basis, and then where does the water come from within the system? The top is showing the Animas at the various USGS stages. So by the time it starts out in Cement Creek, up there in the headwaters at just about 20,000 on an annual basis, acre feet that is. It increases to about this is in 2020, that was a fairly low flow year, not a particularly high flow year. At Silverton, by that time it gains it's at 100,000 acre feet. By the time it gets to Durango, flowing through the San Juan Forest, it reaches 200,000 acres, and then it gains a little bit more when the Florida River comes in, but it's largely a losing reach between the south of the Florida River down to the end, where it joins the San Juan. And then within the San Juan, there's obviously this big mixing point where Animas joins, but there's virtually no flow added from the right on down, Shiprock on down, on an annual basis. So most of the water is happening sort of right here in Farmington, actually. So now I want to talk about the source of metals. Where do metals come from? Because I think everyone hasn't really thought about this entirely, but metals occur in all rocks and in soil. And in fact, most rocks and soil are made up almost exclusively or very high content of metals. So it's a natural part of the geology. Some metals are present in geology in high abundance, and this is a chart of geologists have put together something they call the average crustal abundance of rocks, where they've taken the geochemistry, taking rock samples, they do geochemistry on them, find out how much is in them. There always is a large percentage of iron and aluminum or make up the major cations like calcium and magnesium. They occur in 10,000 to 100,000 parts per million within the soil, and they are usually measured in percent. Then there's something called trace metals, which occur in much lower concentrations: copper, zinc, lead. Most of the ones that we talk about in the water quality context, they occur in concentrations, they tend to be in most rocks around 1 to 1,000 somewhere. And you'll hear crustal abundance thrown around, but rocks really, metals don't occur in rocks evenly across the earth. They occur very centered, very distributed very differently, depending on the source of the rocks, whether they're sedimentary or volcanic in origins. So I'm going to concentrate, your region is right here. This is a soil, the content of metals in soils that the USGS put together, looking at soil pits all over the United States and making this sort of heat map. And I'm showing you manganese here, but you can look up any of the metals. It's an interactive website that the USG runs. It's really kind of neat. And you can zero in to find out. So if you want to sort of get a starting place for trying to figure out what the metal content that you're dealing with in your watershed, this is a great place to start, because the rocks, what's in the rivers are going to look a lot like what's in the rocks. So we're going to zero in on this area right here. This red dot, you're looking at the Colorado mineral belt there, and it's a volcanic region. So you see we're going to have a wide distribution of different availability of soils based on from very hot to very cold, essentially, in the availability of metals for transport. So we've made a really dumbed down geologic map for this watershed to sort of show you where volcanic rocks are versus sedimentary rocks. Almost the entire watershed sits on the Colorado Plateau, and it's made up of sedimentary rocks that have been deposited over many, many years. And the superficial geology of that has weathered in a whole bunch of different geologic substrates, geologic formations deposited in sedimentary in different environments. A very small part of it, of the northeastern corner of the watershed, has eaten its way, largely by the Animas River, has eaten its way into the San Juan volcanic plateau, which sits on the Rocky Mountain province. So it's the only part of the whole watershed that actually is in the different province. So it's eroding these volcanics off the San Juan volcanic fields. And so this is where the center of mining was. It's vein-based. And it's very high in metals concentrations for some rocks. So when you see metals in water or in your bed sediments, they're either in the Colorado Plateau, they're going to be in sedimentary rocks, which are largely what I call silicate bound. They're bound up into minerals that are tightly bound in particles. And up here in the headwaters, we have very complex complex geologic situation that's going on up there in Bonita Peaks, where the metals are largely introduced through dissolution of rocks into basic dissolved ions that are leaked into the streams through out of the mining shafts and out of natural springs, etc., and are formed. You see the formation of rocks in front of you as you look in terms of the low pH keeps rocks in dissolved forms so they get in. So there's a lot higher concentrations. So what does that look like? The metals that you're going to see in the stream bed sediments, for example, are going to look a lot like the soils. So there were available some studies where people have done very detailed geologic geochemistry of the soil and the shale rocks. And so I'm going to share about the Manco Shale. It's not the only sedimentary formation out here, but it was the only one that has a lot of data like this. And what you can see is that this is the metals in the shale rock itself, and then they measured the soils and around it, and then we have measured the sediment in these studies that we've been doing in terms of the local monitoring, and I'm plotting them all together. So the soils are the blue dots, and you can see there's a very close correlation. Here's the high concentration metals, aluminum, iron, and the major cations. Here's the trace metals. And this line up here is like a one-to-one relationships. So you're very tightly tied. The sediments in the bed are these. They're a little bit cleaned of some of those metals, but not much. They all look alike. So the metals that you see in the stream beds look a lot like the rocks themselves. And here's some data showing, here's the shale, here's the soil, that's the distribution you see on the landscape, and here's the bed sediment. You see that this is lead, this is arsenic, this is Vancos. So they're there in proportion to their presence in the rock. How about in the headwaters? The major, really different geology up here. Well, the same is true there. There's a lot of data available from the USGS studies that were done there from 1997 to 2007. So we can kind of construct, you can't really tell the difference in the scales here, but you also see the same thing. In the rocks is the blue, so we have some very high manganese up there, but all of these metals are elevated above what you would normally see in sedimentary rocks due to volcanoes. And you have an extra factor there. Peter Butler talked about this yesterday, and this is what the Bonita Peaks is having to worry about. There's a lot of mine waste up there as well that the streams have access to. So the sediments do look like the rocks, only they're enhanced even more by the availability of metals through various mining practices that have made them more available. So you have an elevation in metals. And what that looks like, let's look back at that map, the soils map. Now I'm going to zero in, and we're looking up here in the headwaters, and I'm showing you lead and I'm showing you aluminum. You won't be able to read these scales, but these are like 1,000 milligrams per kilogram, parts per million. For lead, very high, and then it's going to sketch the river on here, so you can kind of see it's going to come down. This is largely an area around Durango, is right here. And so what this tells you is that soils themselves have a lot of metals in them. This has nothing to do with management. You're going to probably see a gradient in metals throughout the system, and it flows down. It starts entering the sedimentary rocks here. It's still a little cool, warm here, higher concentrations, and then it hits the San Juan, and it's largely flowing. And you see that they should be small decreases. These are more like in the 20 range. As it moves downstream, as you're moving more from the sediments that were laid down in shallow seas, et cetera, as you're moving west into terrestrial environments. All metals are not higher in the headwaters. Here's aluminum. It's only a little bit elevated in the soils up there. It tends to decrease, but you still see the same pattern. And this is the lead you see in the stream bed sediments all the way through the river. Very high up in the Silverton area. Now a lot of these maps are all the same. I'm going to plot Silverton to the left, I'm going to start to the right and end up at Mexican Hat or Clay Hills down here. And the San Juan, the Animas sort of joins right about in here. And you can see the entire Animas is reflecting the same gradient. So they're elevated metals in the bed. And then when you get to the San Juan, it's virtually identical. You could see this very carefully. There's a very close match in the actual concentrations you would predict from the soil map to what you actually see in the stream. And aluminum, same thing, it's elevated in the headwaters, reflecting that kind of a bump right there, but then it's decreasing. You even see increases where it kind of crosses through, it gets a little higher. So good place to start in understanding what's available to the stream is start with the soils. So this is all of the bed sediment that's been collected under the program, showing you're seeing that gradient. So you're seeing it start from in lead up in the thousands range, which is just what the map sort of shows you. You're decreasing. 200 is about Farmington. These are 200 kilometers from the source, which starts at the headwaters of the cement in our mapping system. 100 is about Durango, and 300 is about Four Corners. So you see this decline for virtually all the metals, arsenic. Then there are metals that are not associated with volcanic rocks. Barium is a good example, so I put that up there, and you don't see a gradient. In fact, you tend to see more of that in the sedimentary rocks. So you start seeing that increase, actually. So this is the pattern you see, and depending on whether you're ore-based or not, you're going to see either no pattern, and you're just going to be kind of in the crustal average, or you see a lot of pattern. Now, this is important from a water quality perspective. This is a depiction of the ecological health of the watershed as determined by something called the NERSA index. And this is where people go out and sample reaches a stream. They take a variety of characteristics. Some of them are physical, riparian condition, et cetera. But it's also, they look at the biological community, especially the macroinvertebrate community. People have done research here to sort of figure out when the community itself is telling you that it's either impaired some way or it's healthy. And so they score it as good, fair, poor, and we've mapped that on the Animas here. And you can see up in the headwaters where we just showed you bed sediment, and how it's fairly high in metals, all the way down here through about the Baker's Bridge, and sure enough, the biological community in particular is reacting to that, and is generally not good condition. Once you start getting down into the lower reaches, down kind of in here, in the lower elements, these are kind of within the range, and they've established levels for these various, when the levels are too high, so that you can kind of show that when those bed sediments are getting in good condition, then we start seeing the biological community react as well. So that's a important element of what should you be seeing in your stream beds, which are going to be very important to your aquatic life, and how they're associated with their basin characteristics. Okay, so now what about water quality? And what's in the water? Well, it's still going to follow the same patterns. It's just going to be a little bit more variable because it's also dependent on the hydrology. So we have to start by talking about when you take water quality samples, they're collected, you take one, just a grab sample, and then we typically take another one that we're going to filter for getting the dissolved elements of it. Now, I sort of put that in quotes because it's very standard practice to filter those samples at 0.4 or 5 micron filter and call everything below that dissolved. It's not truly dissolved because it's actually dissolved is really ionic level dissolution, and that occurs at a much smaller, these are particle sizes. So that 0.45 is right there, so rocks and silt, and they'd all be on this side, and that's what we think of as particulate. But there's actually a whole class of solids that are much smaller than that 0.45 micron filter. And they're typically called colloids, which is a very important part of the water quality in the headwaters of the Animas. They are solids. If you're not familiar with what colloids are very small solid particles suspended in a liquid. And good examples of that, you know well, are paint and milk. So when we measure dissolved and we report dissolved in total, we really are missing out completely on a set of solids that are actually being treated as dissolved. And this is very important in this watershed because many of the metals, the incipient metals that occur up in the headwaters are forming from dissolved as they emerge from the rocks and forming colloids, which move easily through the system. And if you go to Silverton and you look at Cement Creek coming in every day, it has like an orange glow to it. And that's because the colloids are these small incipient metal minerals that are forming as the pH dries. So we can't distinguish that very well in our data sets. But here's what you can say is that what's in the water concentrations is very closely tied to what's in the sediment that's being carried by the rivers. So here's relationships between the suspended sediment concentration and the metal concentration. And I'm just showing several ones, and these two on the left, I've done all of this for every metal, so when we publish the report, you'll be able to look at everything that might be of interest to you. But I've picked lead and total aluminum, and you can see what's in the water is very highly correlated with what's in the sediment. And that's because most of the metals are sediment, and most of the sediment is metals, so they have to be related. And they are very tightly related. And the blue dots are from the Animas, and the orange dots, orange squares, are from the San Juan. So I'm just showing you the whole basin here and what it looks like. Up here in lead, now lead is one of the metals that is elevated in the headwaters. It's what I call an ore-based metal. And you can see in the Animas, it's a little bit elevated. It's still following the same relationship with sediment, but it's a little elevated, and that's where you're seeing the impacts of the headwaters contributions. Interestingly enough, the dissolved particles also show a relationship to the suspended sediment, although like the higher the sediment content in the river, the higher the metal load. Has to be that way. Has to be that way. So you're still seeing a good relationship even though it's dissolved, but it's a lot wider variability. Okay, so what does that look like in the water quality at the basin scale? The water quality in the watershed, by the way, can be very interesting locally, but my whole talk today, in the limited time we have, will be about this sort of basin scale patterns. So here's the total concentration. All the data is just plotted. Again, you're going in the downstream direction. So 100 is about Durango. I try to put on these graphs sort of something that tells you when the Animas goes into San Juan. 200 is about Farmington, where we are. 300 is about Four Corners, and 500 there or so is Mexican Hat. So what you see here, you see a lot more variability than you saw in the stream bed, though. And you see the gradient, it exists. I think that gradient is always going to exist. Hopefully when in all of the restoration work that's being done, especially in the headwaters, they're trying to cut down the supply and the availability of the metals, but they'll never be able to eliminate this gradient altogether. They just want to get it low enough so that the water quality is within good conditions for its beneficial uses. But they'll never get rid of this gradient. But what you see then is you see a decline all the way through the Animas, but wide variation on an annual basis. And then you see a lot of variability within the San Juan. Well, let's explore that a little bit. I'm going to break that sort of very messy data set down into time periods related to the hydrology. So here you see base flow. This is what it looks like most of the time. You see a gradient. I'm showing zinc this time. It's one of the ore-based metals. So you're seeing a steep gradient. You have as high as 1,000. Many water quality criteria for supporting aquatic life are not met up in the Silverton area. Part of the idea is to try to establish at least some places. You see a gradient all the way through the Animas. Then you see basically it's kind of a holding steady the whole time through the San Juan. And what you're really seeing here is the play out in this region here of this transformation of dissolved into total. You see a lot of deposition of material into the stream bed for part of the year, and then you see it picked up and moved during these snowmelt events. So you see, now we're looking, I've added in the snowmelt, the whole general level of metals is increasing. The gradient is still there, but it's diminished. In fact, you're seeing higher concentrations move all the way through. So the Animas River is, during snowmelt, is picking up material. It's dropped during the season. Once it enters in, it just keeps right on moving at about the same level. So that during snowmelt, the Animas is really strongly controlling the metals that you're seeing in the San Juan. Most of these measurements are within water quality criteria, so they're okay, but occasionally you get exceedances locally. Finally, that storm that we were able to measure, and that was not a monsoonal storm, it was a regional storm. I remember I was sitting in Athens, Georgia, and I always watch the weather for what's going on out here, and I could see that there was a storm moving in from California that moved through. It was a regional storm, it was great, and we managed to catch it. And so this is extras of that storm. It picked up materials here starting in the sort of lower Animas where the storm was. It just kept picking up material. And that's because it's picking up a lot of sediment as it moves downriver. So we saw, there were many times when you can see the concentrations of metals in the rivers completely unrelated to what's going on in the Animas. Nothing to do with the headwaters. And they can be just as high. They can reach just as high level or higher than anything you see during the snowmelt period from the headwaters. So the factors influencing there are just sheer availability of sediment and the movement of sediment, the ability of high flows to carry them. So it sort of boils down to this. You have one of these kind of patterns. You have a base flow pattern that's accompanying most of the year. There are very few water quality issues, except up here very much in the headwaters, and it's pretty clean all the way through. And you see a sort of a long snowmelt period. You can have some exceedances in that period in some places. And our report will be able to show you more locally where that is. And then in storm flow, you get a lot of exceedances, and a lot of it is occurring in the lower sections of the San Juan because of the massive sediment loads. What does that look like in terms of mass movement? So concentrations is one thing, all water quality criteria work, but it's nice to know where material is being picked up and deposited. So you can calculate mass, you just take the concentration times the flow. So this is the actual kilograms per day on the sample. So you're sort of, now it looks a little different actually, because you're seeing from mass movement viewpoint, during these base flows, it's quite low. There's not much being carried anywhere. You're seeing a little deposition here. You always see that as it's coming through the canyon. You see it generally is prolonged, staying about the same. This little dip right here is where the San Juan is coming in. It's always coming in pretty clean because it's coming out of the dam. And then you see pickup in the dissolved is the blue and the total is, so this is inferentially the particulate, and it's always increasing in the downstream direction. We never didn't see metals mass increase in the downstream direction as it flows through San Juan because it's picking up sediment as it goes. During snowmelt, you see a lot of mobilization of materials that's been stored since the last peak flow. So you have an annual cycle of deposition into the river, generally at okay, healthy conditions, but it's picked up during the snowmelt periods and moves through, and it just moves right on through the system and moves right on out. And then in storms, you just see this massive. You can get just as much sediment being picked up in, especially the lower reaches of the San Juan is a very interesting place in terms of where, and most of the water, there are a lot of water quality exceedances down here. So finally, one of the things I just kind of wanted to share for people working on the river that struck me is this pattern plays out. Not only does the hydrology pattern play out, but the sediments play out really well. In terms of, again, I'm showing you again that sediment deposition in the river. And I wanted to emphasize this. In this case, I'm showing zinc. There's a wide variability over the year. So what's happening is the material's coming down in low flows. It doesn't have a lot of flow to move it. It deposits in various places in the Animas River. There are even particular places it tends to settle. This is a figure that we did during the Gold King when we were trying to understand what was happening during the Gold King movement itself. And we used the WASP hydrology model, which is a transport for materials model. So it's fit to the river, and it will react to the physical conditions of the river, its steepness, its roughness, its width, and whatever. It'll say, oh, this is the place I think it'll deposit, this place it will mobilize, etc. This is a graph of where we predicted, just using the model and the watershed features, where deposition should be happening. So here we have, here's 70, this is where the Animas shoots out of the canyon there at below Baker's Bridge. This is the whole zone down through Durango, so you see probable deposition in there, and that's what we see in beds. There's a sweet spot below Durango. It flows through the Suit Reservation, where there's very little deposition. That's because of the physical nature of the river right in there. And then as it hits a little bit below Cedar Hill and down in the Aztec area, there's more deposition here. It's exactly how we saw Gold King mine deposited, and that's exactly what we still see every day on an annual basis in the river. It's just much lower than what you saw during the Gold King, but we see deposition in that zone through the Animas, picking up and higher in certain locations than others. And then the one thing, and you can sort of see that, here's that Aztec, and you can see that little bump due to the physiography of the watershed is resulting in just slighter high concentration increases right there. So it's very kind of tightly tied. The thing that's really interesting about this watershed then, this is the Animas, now I'm looking at the San Juan. The I sort of talk about the Animas River as being sticky. It's sticky for these metals. And that's kind of over the year period. And it's sticky during the lower flows, and then everything shoots out during the higher flows, and it starts to cycle all over again. And in the sediments, and then once material enters into the San Juan, it just shoots through. There's absolutely almost no difference. There's a few places where it's a little elevated, but for the most part, it just shoots through. I was talking with somebody at lunch yesterday. I appreciate their comments. They were saying people have said that one of the persons told us yesterday that this river is steeper than the Colorado, so it's a little steep for a river. And it also has very well armored banks that are from these vegetation, mostly invasive. And that appears, those both are explanations that are very consistent with what you see. Material does not store in the San Juan, it just shoots through. So I'm getting it in, but it shoots through Lake Powell. So the San Juan funding for wind has sponsored at least 2 or 3 projects that have looked at the sinks for this, the places where metals are going to accumulate where the rivers end. So the University of Utah took some cores that the USGS had taken in 2014. You can see these are down into the sediments of Lake Powell, near kind of where the river joins fairly close. You can see it maintains a pattern where you can see different sources. It's all layered in there because there was probably a monsoonal event in some place in the watershed that deposited this part, and there was probably, you can see that it comes from different places, and they did various tracking, trying to match things like the color and the particle size, but here's the metals distribution through this core right here, and you can see this is lead. You can't read these numbers too well, I'll read them for you, but this whole column here, even though it looks different, this whole column, the lead level is about 21 to 25. Well, the Manco Shale is 22. So it looks just like the Manco Shale, but they also concluded, and I would agree, that there are certain layers out there where it's elevated. So here's a 45. It stands out. You can see all the metals the same way. I'm just picking up my lead. And you also, this one right here was deposited during Gold King, so it was a little elevated too from the period. So you can actually tell historically in these cores what was happening from this hydrologic pattern out there, and it's pretty consistent with what you see on a daily basis and an annual basis. So I'm gonna quit there. I'm sure that was where I was gonna quit. Yeah. So basically, this watershed is pretty tightly tied together, and the San Juan, it's all tied even to Lake Powell. And you can see, there was another USGS project, I'm dying to see what they come up with. They drilled a core, that's part of the wind funding, all the way to base level, to the basement rock in the San Juan. So they're going to be able to reconstruct in this very same way a long history of deposition since the mine was put in. And I heard one comment that was made in some preliminary work where they said, yeah, we can see metals from the Animas, but it's nothing like what was in the 70s. So that sort of implies that what we're going to probably learn is that all of the work that's been done starting in the 70s with increasing regulation on mining, a lot of restoration activity, a lot of cleanup activity, we may be able to see that there's been a benefit to water quality that we're able, in the headwaters of the Animas, that we can tell you because of the history in Lake Powell. So with that, I'll quit on that. All of this material, all of the material will be available to you in a report. I'll even make these data sets available if people want to explore them. There's a lot I couldn't tell you today. I sort of skimmed very fast, but I'll take any questions you have, and I'm available.
I've got a question, if I may. I was here yesterday. I see a lot of good science here, and I really enjoy it. But I guess my question is more from a regulatory perspective. You know, I'm pretty familiar with MCLs and how they were developed.
Okay.
In the Clean Water Act and Safe Drinking Water Act and NPDES, and I spent my career in working with groundwater and other various, but this surface water is pretty new to me about, you know, how it's regulated and what's the regulatory environment. And hopefully you could clear it up in my mind. And then the second part of the question is, has anybody done any risk analysis or risk assessment on what's coming out of the Gold King and what's going on in Animas and San Juan's? I'll let you.
Let's see.
Take a shot at that.
The first one's a big subject. EPA generally under the Clean Water Act has that is a partnership between the federal agency of EPA and the state agencies and tribal agencies that administer the Clean Water Act. So the EPA does a lot of research. That's one thing I do in the agency, and do a lot of risk work and et cetera. And they determine and have recommended for each beneficial use. So there's things like agriculture, drinking water, et cetera. Each one has a little bit different risk associated, and they therefore may have a different criteria, but they have established water quality criteria that are recommended that if you stay below those, you're probably going to be in a healthy condition. And those are actually, EPA may make recommendations and make it available. They do a lot of research to try to back that up, so states have some help with that. But it's up to the states to decide what criteria they would like to adopt, and when to decide when a water body, how often does it have to be out of compliance to be a problem? Once, maybe, just very infrequently may not be a problem. You know, it just happens too quickly. So it has to have some persistence to it, and that's up to the states and tribes. So I haven't done a lot of water quality presentation here today because it's really up to each of those jurisdictions to tell you whether the data we've collected suggests it should be what they call impaired. And that would mean it's too frequently not meeting its criteria. Is that helpful for the first question?
Yeah, I kind of wondered if anybody does any risk analysis to...
There's a lot of, yes.
MCLs or whatever.
We actually have people from the agency that do that all the time, don't we? From New Mexico here, even? I'll let you guys talk about that. There's a lot of risk assessment goes on with it.
When we develop criteria, we use a lot of research that EPA has done because we're not a research institution, but we're making decisions based on that data. So EPA does a lot of risk assessment, looking at, for different, like, especially, I'll give an example, like a toxic metal or something that will affect aquatic life. There are different concentrations that the data shows an aquatic life population changes or it dies off. And so we look at that data to try to establish a level for New Mexico. I'm from New Mexico. So when we're establishing those criteria and those data, we're using the data and looking at the risk assessment, but the risk assessment doesn't give you, where you should set the criteria. It gives you kind of a range, and then you either come up with a range for your criteria, you come up with one number for the criteria, or you look at it like based on the water quality. So it can change with like hardness, for example. So we do that. The water quality criteria is a public process also, so there's input from the public and from stakeholders when we do that. And same with tribes, like any state or tribe that runs a Clean Water Act program is doing the same thing.
So I guess my short circuit was probably, a lot of the stuff I've worked with is human consumption, and a lot of the stream stuff is more biologic and agricultural.
Yeah, that would be fair to say. The interpretation of which criteria to apply would depend on how it's being used. And I can tell you that you have a lot of jurisdictions in this watershed. You have 4 states, and you have at least three tribes who are playing in this part of the watershed, and they're different. They all have them for metals. They're a little different for every beneficial use, whether you're rafting or whether you're drinking. And the only one they're very similar on is aquatic life, and that's because it's kind of a complicated one, and EPA really did do the research on that, and everybody's adopted kind of that approach. But so it's really varied. It was one of the challenges of doing this. There's like, I have applied the water quality criteria to all the measurements, so only 10 different measurements, and there's over 300,000 comparisons to make, depending on all the metals, all the beneficial uses, all the different criteria, so it's complex.
Sounds like something for AI, right?
Yeah, we did actually invent a little pretty simple program to help us do that, but.
Thank you all for your wonderful questions. Thank you, Dr. Sullivan. Okay. Let's see, I know we started a little bit later this morning, so I just want to assure all of our remaining presenters that you'll have your normal presentation time. We'll just change up the mid-afternoon or the mid-morning break and maybe start our lunch a little bit later just to make up some of that time. But to keep things moving along, I guess you got a bit of a preview from Shelley. So I'd like to welcome Shelley Lemon, who is the Surface Water Quality Bureau Chief from the New Mexico Environment Department. The mission of the Bureau is to preserve, protect, and improve New Mexico's surface water quality for present and future generations. As Bureau Chief, Shelley currently manages and oversees 3 technical teams that fulfill the state's responsibilities under both the Federal Clean Water Act and the State Water Quality Act, such as developing and revising water quality standards, collecting and assessing water quality data, managing and reducing non-point source pollution, and implementing surface water quality protection regulations to point source discharges.
Hello, everyone. My name is Shelley Lemon, and I am the Surface Water Quality Bureau Chief for the New Mexico Environment Department. I volunteered today to give our multi-jurisdictional presentation. This is a group of states and tribes where we're continuing the work that EPA started in the Animas and San Juan watersheds. So, as you know, in August of 2015, an EPA contractor triggered a 3 million gallon release from the Gold King mine into Cement Creek, which is highlighted in that little black box in the headwaters of the Animas on the map there. And Cement Creek flows into the Animas River, and then down the San Juan River, and then eventually downstream to Lake Powell. There are 48 mining districts where ongoing releases of metal-laden sediment and water occur, as Peter Butler described and talked about yesterday. I'm not going to focus on those efforts so much as what states and tribes are doing to continue the EPA-related water quality monitoring. So this schematic illustrates the framework for spending under the Water Infrastructure Improvements for the Nation Act, or we like to call the WIN Act. And under WIN, Congress appropriated $4 million per year for 5 years from 2017 to 2021. And the states and tribes, Utah, Navajo Nation, Ute Mountain Ute, New Mexico, Southern Ute, Colorado, and Arizona, in collaboration with EPA, are working to monitor, assess, inform, and act within the watershed to improve water quality. And this presentation that I'm giving is mainly focusing on the orange rectangle at the top, the monitor water quality throughout the watershed, but we're working in other areas to assess the data, inform the public and stakeholders, and act and implement on-the-ground projects. So last year, we gave an update on some of the projects that states and tribes have implemented through the WIN Act funding, and Kate gave some background on that, but this gives a general sampling of what the states and tribes have been doing since 2017. And as you can see, the projects that have been funded under WIN include everything from outreach and communication to watershed planning to monitoring water quality and sediment, analyzing that data, conducting restoration projects and on-the-ground projects. So it's a whole wide range, going back to that other schematic of monitoring, assessing, informing, and acting. A full description of all of the funded projects is on EPA's San Juan Watershed Program State and Tribal Projects webpage. So if you need that link, just let me know. It's easy to find. You can just Google EPA San Juan Watershed Program, and you'll be able to find it pretty easily. All right. So like I said before, this presentation is going to focus on the state and tribal multi-jurisdictional water quality monitoring program. And the states and tribes include the Colorado Department of Public Health and Environment, Southern Ute Indian Tribe, the New Mexico Environment Department, the Navajo Nation, Ute Mountain Ute Tribe, and Utah Department of Environmental Quality. So in 2016, Congress authorized funding under the WIN Act for a water quality monitoring program in the San Juan watershed, and Kate provided some background on that EPA-led monitoring effort from 2018 to 2021. There's some pause in there in 2020 due to COVID, but for the most part, you know, the data that Kate was presenting was from this EPA-led monitoring program. EPA implemented water and sediment sampling with input from the states and tribes, and the monitoring plan included 39 sites along the Animas River, the San Juan River, and select tributaries. And the timing of sample collection was flow-based to capture peak flows and low flow conditions with 4 sample collections per year. Sampling not only included metals, but looked at a variety of different constituents and parameters of interest or concern in the watershed, most notably nutrients, bacteria, minerals in the water. Additionally, there were biological sampling that occurred for benthic macroinvertebrates and habitat, but those were only sampled once per year on a subset of the 39 sites. And like Kate said, all of EPA's data is currently in WQX and available. So what we're doing as the multi-jurisdictional effort is continuing what EPA started, and with that conclusion of the EPA-led sampling, a new cooperative and coordinating sampling plan was developed by the states and tribes and is being implemented. We started last year, and we're continuing through 2024. We will be continuing further, but every year we reevaluate and figure out where we're at and what resources we have and how the plan is going to change. So this plan leverages the individual strengths and capacity of each jurisdiction, and as noted on the slides, the objectives of the program is to provide monitoring data at a frequency greater than the respective jurisdictional monitoring programs. Like someone pointed out yesterday, you know, we're rotating around the state of New Mexico at NMED, and we can only sample a watershed every 8 to 10 years. So this is providing a more continual data set for this watershed. Another objective is to establish a consistent collection schedule across the jurisdiction in the larger watershed, looking at parameter methodology like sample collection methodology, and also sample analysis, consistent sample analysis, so we can compare the data across the jurisdictions. And we've completed 4 sampling events so far, 2 in 2022, 2 in 2023. We have 1 more scheduled in October of this year, and we have 3 events for 2024, but those are still to be determined on when we're going to be out and available. Similar to the EPA-led effort, the project area includes the Animas and San Juan rivers, which encompasses portions of southwestern Colorado, northwestern New Mexico, and southeastern Utah, as well as lands on the Southern Ute Indian tribe, Navajo Nation, and the Ute Mountain Ute tribe. We're scaling down the EPA monitoring scheme, and we're monitoring 13 sample locations across the larger watershed 3 times per year to capture peak and low flows. And sampling location and frequency was informed by EPA's data collection effort. And other considerations included just our resource allocations of the states and tribes, like what could we realistically accomplish with everything else that we're doing, and also, how are we going to pay and analyze for this sampling every year? So those were taken into consideration as well. So how are we going to pull this off? This slide shows just the distribution of labor that we came up with. Obviously, water quality concerns in the Animas and San Juan include elevated levels of metals, but also include nutrients, E. coli, sediments, and minerals. As a state and tribe, we're concerned about temperature, radionuclides, salinity, and also the macroinvertebrate population, fish tissue, making sure that, our river ecosystem is functioning properly. So how we distributed this, the Colorado Department of Health and Environment is taking samples and analyzing samples in Colorado. And then we split the sampling and analysis for the remainder of the sample locations. So at the New Mexico-Colorado border, Southern Ute Indian tribe is collecting the samples, and New Mexico Environment Department is analyzing the samples. And then for the sites from Farmington downstream, Navajo Nation is collecting the samples, and the Environment Department and Utah are analyzing the samples. Okay, so what parameters are we looking at? Monitoring is focused on chemical and physicochemical parameters in surface waters of the Animas and San Juan rivers, with sampling of other media and parameters to be considered in subsequent years. Like I said, our monitoring plan is flexible. It's a living document. We review it every year. And if there are things that we need to add or take out, that'll be done as we learn more about the watershed and the data. Our standard analytical suite includes metals, both total and dissolved, nutrients, and minerals. We're also collecting E. coli bacteria and then physicochemical parameters when we collect the samples, such as temperature, pH, DO. And only Colorado is collecting metals and sediment at this time. They're grab samples, and I have an asterisk next to E. coli because we're having a little bit of difficulty with that. E. coli collection has been a little bit variable, but we're looking into options for this analysis. And currently in 2023, E. coli has not been collected by the Southern Ute Indian tribe. So we're missing a little bit of data, but we're trying to work on some issues, mainly having to do with the hold time and figuring out how to get it analyzed. Okay, So what are we going to do with the data? We will eventually upload the data that we collect across the jurisdictions into WQX. Once it's been verified and validated, we're going through that process right now with last year's data, and we're planning to upload our data pretty soon, either this summer or early fall, so it'll be available in WQX. Once it's available and it's been verified and validated, the states and tribes can use it for assessment purposes. For states, that means, using the data in our integrated reporting, so our 305B reports and our 303D lists that identified impaired waters. And through this multi-jurisdictional effort, we are planning to create an annual report that summarizes the spatial and temporal trends in the data and assesses the current condition of the watershed. The plan is to have the first annual report come out later this fall. And with more data, obviously, current conditions can be better assessed and communicated, and we can take action more timely. So we've had a couple of implementation hurdles. Like I said previously, the E. coli sampling has been variable, but we're hoping to have some samples analyzed for E. coli for the October 2023 run. We're also having some issues with our DOC analysis, and Utah and New Mexico are reassessing our DOC analytical method due to recurring errors. So we currently don't have any DOC data, which is linked to understanding metals and metal concentrations, and criteria to protect water quality and those designated uses. We've also had a lot of staff turnover in multiple agencies across the jurisdiction that has led to capacity issues and challenges with sample collection and scheduling, but we're still on track to collect the 3 coordinated sampling events in 2023. And as you all know, no 2 years in flow are ever the same, so timing that sample collection so that we get different flow regimes is also, we can predict where we're going to be, and when we're planning out, like October, okay, maybe it'll be a low flow, but last October I was doing work in the Gila and it was the 3rd wettest October on record. So, it goes with the territory. So we're planning around those trends to anticipate sample collection to get different parts of the hydrograph, but it could be impacted by environmental weather anomalies or dam releases, localized storms, et cetera. And our data management issue, as Kate pointed out, trying to assess data across the jurisdictions is really complicated, so we're trying to figure out how to come up with a method that is simple and easy to understand and takes into account the watershed as a watershed, not New Mexico or Colorado or Southern Indian tribes. So we're trying to get a more broad-based data assessment. All right, so our wish list and successes, I do want to point out that, successes of this effort has definitely been just the collaboration between the multiple agencies. We've been meeting monthly, bi-monthly for a long time, and this effort has just strengthened our relationships between and across the jurisdictions within the watershed, and the communication has really been great to understand what each jurisdiction is doing, how it relates to what we're doing. So the collaboration has been really great. I think the annual report is another success. It will summarize what we've been doing and looking at the spatial and temporal trends, which can make our jobs easier for deciding what to do, how to act, where projects need to be implemented, where the problem areas are. We're also looking to the future, talking about different constituents and analytes that we might want to consider sampling for, like priority pollutants, PFAS is the big one, some pharmaceuticals or other parameters of concern, or just, I don't know what I was going to say, so I'll skip that. And then we're looking at also fish tissue analysis and doing some additional fish tissue analysis with different types of constituents. Typically, it's mercury or PCBs or selenium that you look at, but we're thinking of other types of pollutants that we might want to consider. And then we're also working through E. coli and DOC issues, which could benefit all the jurisdictions and create for a more unified data collection effort. So I think that is the last slide. So I will open it up for questions. These are the people involved in the different jurisdictions in the states and tribes. And with that, I'll take questions. Yeah, no questions.
I got one from...
Okay.
Let's see, they were just wanted to ask where the funding for this jurisdiction-led program is coming from.
So it is coming from the states and tribes. So it's no longer funded through the WIN Act. We're piecing together different funding sources, and each state and tribe is responsible for funding their portion of this effort. For New Mexico, we received some of the Gold King Mine settlement funding, so we're using that as an injection to help continue this effort. We also have our regular Clean Water Act Section 106 funding and our 319 funding that is paying for some staff time. So it depends on the state and tribe to come up with the funding, but it's not being paid through the WIN Act anymore. If there are no other questions, I will mention, I talked about staff turnover. We just had a position post in the Surface Water Quality Bureau for our watershed protection section manager, who's responsible for the non-point source program. So if you know of anybody, contact me. I will send them a link, or if you want me to send the link to distribute to your network, let me know. Thank you.
Thank you, Shelley. Okay. So we have one more speaker before we get to our break for the morning, where we'll be resetting the room. I'd like to welcome Dr. Ronalda Sosi. She's an NSF EAR postdoctoral scholar at Montana State University in Bozeman, Montana. Beginning in the fall of 2023, Dr. Sosi will continue her academic journey as the first Indigenous faculty member at New Mexico Tech in the Department of Earth and Environmental Sciences, and serve as the new director of the Environmental Science program. Currently, she's working on a point-of-use filter optimization project and continuing to work with Indigenous communities and water challenges. Thank you, Dr. Sosi. There you go. There's that.
I think I'm not going to mess with the microphone. Yat she nanisht ajit khabahanisht nasha shabashish chin ashe dashedo ashe dashnal thotlakand ashiyaho. My name is Ronalda Sosi. I am very delighted to be here and share what I've learned, what I'm going to be doing, our current collaborations with Navajo Technical University and New Mexico Tech. But first, and most importantly, I'd like to acknowledge the original inhabitants of this area and this land, which are the Diné, the Zuni, the Utes, the Apache, and just to acknowledge them in the spaces, academic spaces that we're in. It's really important. Oftentimes, we don't get that as Indigenous peoples, so I'd like to take that time. And in addition to that, it's really important to have representation from communities in which you are presenting about. So I was quite surprised when I walked in. But without further ado, so like I said, I'm Dene, originally from Tuatlacan. Does this have a pointer? Which is this area where there are a bunch of abandoned uranium mines, which is really the motivation for a lot of my research and my educational path. Most importantly, I'm a mother, and I often put this slide in because the work that I do impacts future generations, and that includes my children. And so I consider myself an environmental chemist, and of course that's my educational training. Trabaja is my matriarchal clan. So when we're conducting research within indigenous communities, it's really important to understand those approaches, which really includes axiology, which represents value systems within indigenous communities, epistemologies, our ways of knowing our indigenous knowledge, and then ontologies, in which the way in which we see and view the world. So for me personally, that came through as Dinesh science, which I'll explain a little bit later in the next slide, in this slide. So growing up, I was always taught these philosophies of Nsahakes, Nahata, Ina, and Sihasin. Using these concepts helped me develop that research framework in how I'm going to conduct research within my home community, but other communities within the Navajo Nation, but other indigenous nations, and also how all of these different R's here that you see, representation, reciprocity, those play an important role when you're conducting research with and in indigenous communities. So I just wanted to share a little bit about my thought process and my research framework that I use. Oftentimes, indigenous communities have some of the most impacted by mining operations in close proximity of their hometowns, of their communities. So I'd like to share, I always share this slide or a similar slide to it to just demonstrate the amount here that's happening in the Southwest and the West Coast. So this here is a photo of two Diné women bringing in uranium ore. And that really is one of the reasons why was the motivation for me in my own home community is to address those environmental problems, those environmental impacts that are legacies that we're currently dealing with as indigenous communities, as Diné communities. And so part of it was first doing in situ studies at the University of New Mexico, but I wanted to do something more broad at the macro level. So I did a doctoral degree. My research thesis was covering and looking and examining and understanding the impacts of water contamination in in these types of wells at the point of use. To me, there's plenty of groundwater studies, but not enough in terms of historical studies. But which also led me really to my postdoctoral research, was really thinking about how can I not only find the problem, but solve that problem temporarily, and that was developing a point of use filter that I'm currently working on. And in addition to that, my current and future collaboration with on the N4WPP project, which I'm going to speak about as well. So part of my postdoctoral research was to really continue these collaborations within the communities, not only in Navajo country, but also in Crow country as well, because they're dealing with the same sort of water contamination issues. They're have more biological contaminants, nitrates and things like that, whereas on the Navajo Nation, it's more metal contaminations, arsenic specifically, and uranium. So part of that was really to think about this thinking about a point of use filter that can be handheld, that can be given to a community member. So if they're accessing these unregulated water sources that you saw, like windmills, that are meant for livestock only or agricultural purposes, if they're accessing that, they can take a filter, connect it to the point of source, and then go on to have remediated water or processed water that's binding and removing these elements of concern. So this, I like to show this because this was my very first prototype when I first started. I didn't know really a whole lot about design and engineering and research and development, and so luckily I got the postdoc in civil and environmental engineering at MSU, and we have now come up with this sort of smaller, more compact design. It's ready for the next phase, which is implementation. And I was working with the mechanical engineering students at MSU to develop this filter. This is another version of it. But it's basically just so that it connects to the water source, and whatever is coming out is remediated water, or at least metal contaminants that are below the environmental contaminant limits that is established by not only tribal EPA water quality standards, but also the US EPA. So part of this collaboration between New Mexico Tech and Navajo Technical University is really a joint endeavor to install water filtration equipment and testing facilities within Navajo Nation communities. And these sites will be used to train students to test water quality, to maintain these systems, and also provide an educational pathway for these students. The water purification technology was actually developed using a hollow fiber membrane that is based in direct contact membrane distillation process. It's like a mouthful. But it was developed with the Petroleum Recovery Research Center at New Mexico Tech. This system filters out phosphates, nitrates, heavy metals, and salts. Essentially, it goes through a desalinization process, and the 3 phases of this project is first site selection, where students will go out and collaborators will go out and determine what sites to go, where would be the optimal place for these systems to be set up. The second part is installing the filtration systems, and then third is accomplishing the long-term goals of eventually handing over this filtration unit to communities, building capacity at their level, educating community members. So in addition to that, we also have an education component where we are trying to develop the local workforce in those communities. That includes having a water database management system in those communities, a water sampling and analysis techniques, unit operations, as well as data analysis. These are things that we would train students and to participate in along the way. In addition to that, we have an education model which really promotes this process of going from high school to undergraduate, like Navajo Technical University, and then creating a pathway to graduate work at New Mexico Tech, or just going straight to New Mexico Tech. Either way, that works too. And so, in addition to that, we have a public outreach component. Most importantly, part of this first part is the students. The students are really important in making these, going out, making these connections with these communities, going out, learning about all the different needs of the communities, and also going to attending chapter meetings, help in assisting and organizing water symposium, which I will also talk about a little bit later, and other public outreach activities that we have thought about. In addition to that, we would like to educate members about not only the filtration system, but system maintenance, as well as conducting simple repairs, and really generally, most importantly, about water quality and what that means. And the fourth component is capacity building. This I kind of spoke to a bit earlier, is having this filtration system being turned over to the community and having them be able to keep it up and continue running that system in an efficient manner. And then most importantly, we're still going off of this principle of tu'e ina, which is water is life. These are all our collaborators at Navajo Technical University, as well as New Mexico Tech, the New Mexico Bureau of Mines and Geology and Mineral Resources, and also we have collaborator at PESCO who helped us design the system. So the system really went through a collaborative effort, not only with the PRCC, but also through PESCO. PESCO actually brought that. If you saw in one of the photos, we built two systems, and they were brought out to two communities, one at Navajo Technical University and the other one at a different community. And they built it, they brought it out. Now we're getting on this educational pathway and sort of maintaining and understanding how that system works and getting it started. And with that, I'd like to say thank you for paying attention. If you have any questions or any comments, feel free to reach out to me. My address at New Mexico, email address is posted. And without actually, one more thing. I forgot, the water symposium. So we are hosting a water symposium for geared towards Mexico high school students. That's going to be being held in Gallup on November 5th. This fall. So if you have any collaborators or connections at local high school students and have students that might be interested in participating in this symposium, there's like a water competition. We're going to have not presenters, booths and people coming over, a number of different activities. So that's going to be held in Gallup at the UNM Gallup campus. So, and other than that, thank you.
Are there any questions for Dr. Sosi?
Just curious, how do you dispose of the filtrate from the purifiers?
So that I don't know the answer to. I'm sorry. I know more about the handheld system. Those systems are meant so they're supposed to be interchangeable cartridge systems. So you could put solid phase media inside it. Within the solid phase media, you can extract and remove. Not only can you bind, but you can go back through a different chemical process to remove those arsenic and uranium that are bound to the surface of those composites. I've tested a number of different composites that are selective for arsenic and for uranium, but I've also tested activated carbon. Unfortunately, there's really no secondary use for arsenic or real use for arsenic, so most often those will just be concentrated and hopefully disposed of in a safe manner, which is one of the the disadvantages of solid phase media for arsenic removal is most of the times when we have systems like that, they end up just being thrown back into the landfill and being held there until they're able to leach out again. For the water purification system, if you speak with my colleague, Mr. Steve Gray over there, he might be able to provide further information. I'm really new to that end of the N4WPP project, but I think, and also if you contact my colleague, he's not on here. I'm sorry, he's not on here. If you contact me, I will get you in contact with the right person. Sorry.
Thank you for your presentation. Have you guys looked at produced water reuse in addition to just the livestock wells?
Yes, we have, and that's an ongoing project that we have with as part of the NW4PP project, which is also, I believe, the other filtration, the latter part with the units that were built by PESCO.
Hi, thanks for your time. How much did that system cost? I mean, versus a commercial one that's viable off the shelf?
I'm sorry, I do not know that information, but if you email me, I will get that information to you. Any other questions? I did not expect the cost question. But we built these systems in collaboration from a grant, so they make it free for the community. So if we're looking at something maybe in a non-native community, a non-indigenous community, we could probably talk about that and have potentially collaborate on an effort in the future. Okay, thank you. Yeah.
Good morning. It's such an honor to be here with all of you. Happy summer. It was summer solstice yesterday, so you were ready to clap. I like that. Thanks for adapting to our circle idea. We just felt like the work we're trying to do is very much in conversation and exchange and dialogue, so it just felt natural and right to reorient. So thanks for being flexible and do what you need to do to be comfortable within that structure. Great. And our Asekia leaders, who I said we're going to call you up later, just go ahead and sit with us now because we like your company and it'll be more fun that way. So thanks, guys. We're going to introduce you in a little bit. So it's an honor to be here with so many folks who are caretakers and stewards of our beautiful and vital waters. So I thank you all for your important work. What we're going to cover in this session called Asekia Drought Challenges and Collaborative Strategies for Resilience in the San Juan Basin is to share our community-based planning approach and our guiding concepts. We're going to offer highlights of what we are planning to achieve. We're going to relay efforts to identify appropriate drought-tolerant crops, and we're going to host a dialogue with Asekia leaders sharing their concerns and solutions that will lay the groundwork for this project to be implemented, and is really the kickoff of the working group that we're forming. And we're going to follow this session up with a sort of smaller, but you're all invited to if you're not already going on the fantastic field trip. But when that filled up, we thought, well, we'll just go ahead and make our own party over here, because to me that's as party as we get. We're having a conversation about Asekias. That's what we want to do, and planning, and all collaborators, anyone who works with the Asekias, has a vested interest in the watershed, is welcome to participate. So I'm Serafina Lombardi. I work for the New Mexico Acequia Association. I'm a subsistence farmer, but I'm also our program director. We work in all 22 counties where we have acequias in the state, and we do everything from federal, state, and local policy advocacy for acequias and acequia communities to youth education. And a lot of our work is supporting acequias as political subdivisions of the state. And we've been in a long-term collaboration with WERI, and we're gonna unpack kind of the newest iteration and projects we're working on today. So I wanna just start by sharing some of the guiding concepts that ground the work that we're doing. One of these that you will find in the description of this gathering is the knowledge that acequias are vital instruments for aquifer recharge, food and fodder production, community institutions that are passing on agricultural traditions, land ethics, and overall vital instruments for regional adaptability to climate change that we're already in. So there's a lot in there, but that sort of encapsulates acequias aren't just good for the irrigators, for the ditch members. Acequias provide benefits to anyone who lives in a community that has an acequia passing through it, and in more ways than we often understand are benefiting from them. And some of the previous work that WERI's done has proven that scientifically, and we are building off of that understanding. Another premise is that the task of adapting to drought conditions is urgent, and we have to do this through collaborative and creative solutions that address the situation. The overarching goal from a New Mexico Acequia Association standpoint is that we want to see the persistence of viable agricultural systems for thriving acequia communities. Again, the word community is used to make sure we're writ large. It's not just acequia members who are benefiting. It's not just the ranchers and farmers off these ditches. This is a community benefit that we all rely on for our communities to be livable and viable in the future. And so we are also very committed in this work to tangible outcomes. There's research component, there's conversation and needs assessment, but we want to see real projects that are addressing the issues and the needs that communities are bringing to the forefront. So in that process, we're grounded in listening to the folks who are on the ground, who are managing the water in the ditches, who are growing food, and to base our work off of their interest and insights. So with that, we got to a point where the backstory is, we got to a point where we were identifying a real need and a major gap in the knowledge we had. And at NMEA, we realized we needed help. We needed collaborators to figure out how to move forward. So in the work I do at the New Mexico Acequia Association, as an organization, we're working with hundreds, a minimum of probably 300 to 400 acequias over the course of a year out of the approximately 700 acequias across the state. We're taking phone calls about every kind of issue you can imagine that comes up on the ditch. And I was getting more and more calls about flooding issues, about siltation, about not having enough water in the ditch to get folks what they needed, not getting the next cutting of hay because the ditch had gone dry, and people were looking for solutions or answers that I didn't feel I had adequate answers to. And so I started bugging our friends at WERI, like, SOS, help, like, I need more than Serafina's ideas about how to address this, and we've turned this into a long-term project to try and explore what those ideas are. So in building off this collaboration about 2.5 years ago, we started with a focus group, and we've built this into a larger conversation about how to address the concerns that acequias are bringing to us. So we hosted, co-hosted a few online sessions to gain input from a wider audience of acequia leaders and other stakeholders. We ended up forming a group that we called Building Agriculture and Water Resilience Working Group that came out of that, and that's based in the Northern Rio Grande, Rio Chama basins. And we've been collaborating also with the local Soil and Water Conservation District, we're big friends with them, and also County Extension. So it's, we want all different kinds of agencies at the table who are providing services and have a lot of insights about the watershed. So we started these ongoing conversations over Zoom, and Connie and I worked with this group to further identify what their priorities are, what their key issues were in their own basins and kind of across basins, what was similar, what was different. And the outcome of these conversations was to figure out what funding sources help us address these issues, and then we went ahead and applied for that funding sources, and then we got the funding. So very excited about that. So we applied for the NEEF Organic Transitions Grant, the BR Water Smart Drought Resiliency Program, and both of our orgs separately applied for water stewardship programs that we also were awarded. So again, in that vein of tangible, immediate outcomes are really vital and also serve as case studies along the way to inform this body of work. So in the Organic Transitions Grant, which is entitled Expanding Organic Systems to Reduce Water Demand and Increase Agricultural Resilience in the Southwest, we started with this premise that really traditional farming is very similar to organic farming. So that's kind of our version of organic, low inputs, low tillage, all of that, and that we're working with nature. But that we also need to find ways to harness crops we can grow through increasing dryness. I didn't want to say aridification because it makes me cringe. So some of the outcomes of this are going to be really trying to identify what are these concrete practices? How do we keep the water in the basin? How do we sink it to recharge our aquifers? If we don't have acequias, which are providing active recharge to wells in our communities and habitat, then how are we going to get that? And at the same time, how do we counter, I'm sure a lot of you have seen this, just destructive arroyo flows. I mean, we have people who can't leave their homes for days because arroyos cut them off. So, and that's not like isolated incidents, that's many communities have that issue. So we're trying to consider wider community interests, agricultural interests, and ecological benefits, and marrying all of that together. So out of that, we're going to have a toolkit and a handbook that will help irrigators and leaders to understand dryland farming protocols and other methods they can apply to the watershed. And we're going to match that with technical assistance and outreach. And briefly, with what we're calling the acequia DRP, or Drought Resiliency Program. So we have a number of outcomes that we're working on there. One of them is creating a socio-hydrologic model to support, or I should say models, to support decision making. I don't need a sip of water. Excuse me. Some of you must be more practiced at talking without getting a dry throat, because it's getting me now. So we're going to develop that model in the San Juan Basin, but also in the northern New Mexico Basin. And that will serve as a basis for other models, oh my, excuse me, in other basins as well. So we're going to, water sharing is a really key strategy for us, how acequias have managed water for, if not centuries, millennia. And we're going to be learning from what has been working, where we need to adapt water sharing, and understand that that's what many cultures have done to address water scarcity, is how to share it equitably in times of need. So we'll be building off of existing practice there, and we're going to start regional water planning, and at the same time, we're going to be building a model that we can share with the Interstate Stream Commission for their regional water planning that involves a very community-based process, and they're a partner. This has never happened to me before. I think I might be allergic to something, but thank you for bearing with me. This is not my usual presentation voice. But I'm brave and I'm going to keep going. And then we're going to turn that into a website that will serve as a hub for stories and resources and connecting across basins about what's working, what's needed, and how to move forward. So the next piece I'm going to just summarize here is out of all these, we've done a workshop, we've done these working groups, a vision started to form of like, how do we marry all these different needs together? So from that, we started to collaborate and collect ideas through our listening about how can we address, these questions. What are we going to grow? Who's the next generation of farmers? How do we address destructive funding our communities are impacted by? What can we do to improve and care for our lower watersheds, the valleys, the badlands where the BLM, it's encircling our farming communities often, and how to make life less dangerous. So in dreaming about what that would look like, we started to develop this idea, really kind of expanding the Youth Conservation Corps concept and merging this very cooperative approach. How do we harness the arroyo flows? How do we support aquifer recharge? And we imagine young farmers and other folks interested in watershed restoration, landowners and researchers all coming together so that we have an active year-round crew of people addressing these needs in a very holistic, intersecting way. So the main goals would be that we're supporting young agriculturalists to be remunerated and be invested in the watersheds that are their future through these changing and uncertain times, helping them adapt to drought conditions and potentially expanding the zones of where we're even considering farming, and how we use those arroyo flows to recharge aquifers while also reducing and mitigating their damaging impacts. And the outcome ends up being to address this dramatic increase in fallow land. Pairing that with the young farmers to care for the land and the watershed team of experts who are really going to help inform what strategies work and monitor those strategies to evaluate what's working, what do we want to change, how do we do it differently. So in summary, we're calling this full-time continuous crews of young farmers and watershed restoration practitioners to preserve and extend cultivation to the drier parts of the landscape while also mitigating community flood issues. So we have a lot of questions we're still looking at about how to realize that, but that's what basically the Northern Basin has come up with as something they're aiming for. So out of community dialogues, we've evolved it to this concept, and there'll be many other projects and pieces, but I'm going to leave it there now that my voice has recovered. What a relief. And hand it over to Connie to share some more.
Thank you, Serafina. Serafina did a beautiful job of introducing you to our overall vision, and I'm going to give you a few more details, and I'll be able to skip through some stuff because I think we've covered some of it already. Yes, there we go. So as Serafina mentioned, us at the Water Institute, we're working with the Interstate Stream Commission on their 50-year water plan. And what we did, you can see this map here, we picked a variety of regions that had some variability, and we did focus groups with those regions, collected some of the perspectives in order for these regional perspectives to contribute to the Interstate Stream Commission's 50-year plan. So this was a bit of a starting point on on these specific projects that us at the Water Institute and NMAA started to work together on. You can see the cover of our report, which is online. The next page will give you kind of the citation where we actually include the full transcripts of a lot of those particular focus groups. One of the things that's really been important to the work that I've been doing over time is the necessity that all of the planning efforts be really a community-based effort. The process that I've, synthesized and followed and is included in that report as well is shown here, that the regional planning process for water and community resilience really needs to have some essential components. I won't go over these in detail on this slide because I'll cover them on the other slide, but gosh, this is small here. But in essence, number one, we start with the community, the visions of the future from the community. Number two, we help, obviously there are collaborative networks that are out there. You guys are doing a ton of great work. Whatever we can do to support, to increasing those collaborations of partnership more onto regional scales is a part of our activity. Building mutual understandings of really what's going on. Quite often, there are riparian people working on the perennial flows, and there are upland people working on rangelands, and never the twain shall meet in terms of our scientific disciplines. And a lot of our management tools don't facilitate a full, complete watershed approach. And so that, I think, is an important component. Where do we want to go? Number four, identifying potential pathways. And number five, whenever we implement actions, everything in essence is an experiment that can help us understand how effective those strategies are and to really figure out what the combination of strategies are. So the focus group that we did in this region, I'll just read briefly a very short selection of highlights from the executive summary. Visions for the future: use available surface water to continue farming as well as serve the needs of other water users. Increase adaptability to diminishing surface water issues. Declining snowmelt runoff, erosion of bare soil negatively impacting soil health and surface water quality, and strategies. Restoration projects to slow and spread runoff across the landscape, which you'll see quite a few of this afternoon. Modify infrastructure to capture stormwater, and do education and outreach that promotes water sharing. A snapshot of kind of where we're starting. As Serafina talked about, the USDA NIFA grant, it's part of the National Institute of Food and Agriculture Organic Transitions Program. The working title that we're using for this project now is a bit of an adaptation of our proposal title. So now we're calling this The Future of Agriculture and Water in New Mexico, Building Resilience Through Organic and Traditional Approaches. This particular project lets us look at things holistically. It allows us to really help build those collaborative networks a little bit further, make more connections between producers, people on the ground, community members, and our scientists and agency support folks, and then do that work of building the mutual understandings. We have NMSU folks, us at the Water Institute, Agricultural Research Station folks, Kevin Lombard, folks from the Plant and Environmental Sciences, Kevin is also there. Jay Lillywhite from the Ag Economics, the head of that, a farmer, a nonprofit. Serafina's on the advisory board. We've got quite a few others there as well. So that's kind of our starting point for that project. Really what the bottom line is, keeping water in agricultural valleys is critical for both agricultural and community resilience. We know farmers get a bad rap. Of course, the majority of the water that's being used in regions diverted is agricultural. But a lot of times the return to the aquifer is really not adequately recognized and supported. And we know that when there's water competition, farmers are really where we look to first. But do we really understand the regional implications of the fallowing trends? What happens to the groundwater? What happens to our river valleys? These are really the questions that we're asking. And as Serafina has said, you know, this is a struggle that many farming communities have around the entire state. And one statistic from the USDA census is from 1997 to 2017. Irrigated agriculture in New Mexico declined by over 26%, which is a very large amount. And we've seen groundwater levels dropping in all sorts of regions. So these things are tied. Agriculture has multifunctional benefits, and certainly we all want everybody to be thriving in the community. So that's really the bottom line. And as she mentioned, what we aim to do is to really help develop those strategies that can support resilience, that can really help young farmers start careers, that can help communities address their issues. And it really is this tie between strategies of field cultivation that can extend cultivation, that can include the drier parts of the landscape, and harnessing the flood flows at the same time. A lot of times folks have to go to drip, and that, you know, just to keep production going. And of course, that's not going to recharge the aquifer. And if that's a need, and it is in many communities, not all, but in many communities, then community aquifer recharge projects are something that we really need to start to look at. She's gone over the approach, you know, working groups, looking at alternative crops, identifying combinations of strategies. That really is kind of our fourth tenet, identifying the potential pathways of resilience. You know, a central question of this work is if expanding these holistic systems, organic and traditional systems, can support small farms to achieve the water demand reductions needed for preserving cultivation across agricultural valleys while achieving overall both agricultural and regional resilience, really. You can see here this particular diagram is how we start to look at it. You know, there are different approaches. There are approaches in the fields where we can actually preserve cultivation. And then once again, as I mentioned, looking at the arroyo flows, the harnessing of the flood flows, is really a different type of practice. And so here on the bottom, we've started to talk about this concept, and there's a couple of different elements to it. There is the idea of continuous crews, YCC kind of ideas that can partner with farmers that cannot put all of their fields under cultivation, really give, you know, there are programs like Grow to Growers in Albuquerque that do similar types of things, where you actually have farmers partnering with young farmers to give access to land. What we're talking about is kind of expanding that to its full potential. If we could have full-time crews, and this is very much, as Serafina talked about, a concept that we're developing in northern New Mexico. Different regions are probably going to need different formations of this type of thing. But you know, all of us in this room, we have a part of the story, and there are great collaborations that get started on specific elements. Obviously, the mine spill itself is a good example of that. One thing that we have the ambition to do is lots of community members have issues but don't have a place to go. One of the examples when we talked before was there was a particular grant that one of you guys had to give up because it turned out that the details didn't work out in the end. Being able to pull all of us together as a collaborative network that can actually support communities, we're trying to see if there's ways that we can build capacity for that concept. And so, you know, it could be, Serafina was just telling me an example of a program she did years ago where young farmers actually went in, worked with the community, built up an acequia, restored that particular acequia, and the community came and volunteered. If we could do events like that with workshops where people can come and say, this is my problem, and we actually have access, creating this bridge between all of us and the community itself, so that, you know, if folks have a problem, our expertise can help them figure out what the resources are, the funding mechanisms, and so forth. So, as you can see, we're at the beginning of this, and it's not as though, you know, this is a completely new idea, but it is true that the community needs are outstripping the implementation of solutions, and this is the space that we're really trying to occupy. So I'll finish up with just a couple more details. Crop choice, of course, is an extremely important component. Kevin's going to talk about some of the research on extreme drought tolerant, you know, crops that really have a much lower water use component. Not an easy thing to do. Folks, changing crops is really not an easy particular aspect. But if there's ways that we can expand cultivation, if these crews can actually start to do some of these practices, those are some of the ideas. And then, of course, the support, if somebody does want to change crops. The Acequia Drought Resiliency Project, the Reclamation Project, this is where we're really focusing more. The previous project has a modeling component, and here I'll explain the modeling component a little bit more. We have a model built in southern New Mexico, which we're going to be applying to northern New Mexico, and we're going to also be building a model here. Lots of data, lots of work has been done in this region, so a big part of what we're going to be doing is synthesizing not only the work that's been done, but also looking at the socioeconomic indicators that tell us if these different strategies might be successful. So integrating livelihood, economics, those sorts of things into the model itself. Here, we're developing the water budget modeling tools, and today, here we are starting to convene a regional working group. One of the aspects of this is that the Interstate Stream Commission, Sarah could tell more about it, but I know you guys are at the very beginning of this process of really opening up the regional water planning process. One aspect of this particular grant is that we have a partnership with the ISC, and the ISC is going to be giving us match contracts to really synthesize the information from the different regions from this region and begin the process of what a regional water planning plan can look like for this particular region. So that's an exciting part of legislation. Part of what's exciting about it is that it's not completely defined, and that this process will actually help define it. One thing that everybody that I know that has been involved in the ideas of that plan, one of the things that we're all really pushing hard is that those plans then can be funded, have access to funding. I understand that some of that was taken out of the legislation, so we'll see how that actually plays out. The legislation isn't the budget, so it's not necessarily that it won't happen, it's just just that hopefully we can actually define that. So plans leading to actual funded projects is an important component of it. So a water budget model. Most everybody in this room is going to know what that means, but it's like a bank account. What comes in, what goes out? What do we have access to? And really the idea is that the strategies can target the functions of the water budget and really assess for a region, not just for one farm, not just for one small little area, but for a region. What are the implications? What are our groundwater situation? How is our entire region doing? Some of the results of us at the Water Institute, we have a statewide water budget model, which relies on information like the 5-year OSC reports and so forth. And so there's some roughness in that, of course. 5 years is not, a snapshot every 5 years isn't very accurate. So we also have customized regional models, and that's what this project is going to allow us to do, to build a customized model that really tries to serve the needs of the community itself. But we know some of the results from the statewide model: less water quantity over time, our monsoonal peaks end sooner. That's what this graph shows. Trends of surface water here, the prediction from the climate models show significantly less, prediction of significantly less surface water availability. So let's fine tune that and use all the great data that's been in the work that's been going on to start to do that. One suggestion that was made was an understanding of the relationship between snowpack and the water availability. Let's get that into the model right off the bat. This just shows the regions. The green areas, of course, are the areas that are, the official name of it, conveyances for irrigated agriculture, so you get a sense of where those are. And of course, the blue dots are USGS stream gauges. So that's some of the data that we're starting with, and just to give you a visual on the regions themselves. So in conclusion, really, the idea here is to start to develop this structure, connect with existing collaborative networks throughout the region, and then develop an approach to further that connection. Like I said, the community base is really fundamental to this, and then identify those strategies and those actions, and let's find ways to actually implement them and have that circle back to contribute to our understanding. So I'm going to turn it over to Kevin. Kevin's going to talk a bit about his research, and then we're going to open it up in terms of the panel itself. So Kevin, let me see. I think, yes, here we go. Great.
Good morning, Yatabina. Kevin Lombard with the Ag Science Center at Farmington, and I wanted to give the chance for the panel to kind of maybe get some questions going. So the San Juan River, Animas, La Plata that we've been talking about here, how many people actually farm that are in the room? Raise your hand. How about ranch? Anybody ranching? How many people go to the local farmers market?
There's 12 head, count as a ranch.
So, we're a pretty diverse communities of agriculture and water users, and we have to share water with municipalities now with growing urbanization. The acequias, or ditches that are called around here, really form the lifeblood of the valley and the community. It's so much so that you can see the agricultural lands from space. And where my facility is up on Navajo Agricultural Products Industry. It's an 80,000 acre irrigated farm with large center pivots, But there's this tradition of agriculture in the valley that's largely furrow irrigated. We're starting to see more sprinkler and pivot type irrigation coming into the valley. What does this mean for resiliency? What does this mean for new crop development? Major crops that are grown: potatoes, corn, wheat, barley. We're high elevation here. There's folks that are interested in specialty crops like grapes and berries and whatnot. How are we going to use technology and agricultural science to kind of guide this resiliency in our community? Are folks going to adopt technologies like soil moisture probes there on the left, or weather station data? That there's a poster that we have over here to inform irrigating using climate data. So with that, I'm going to just put a plug in for our field day, and I want to have the conversation begin with our panel, and maybe you all can introduce yourselves, and we have a mic here that we can also pass around and ask questions, and then we can continue this conversation in the field as well, and I think that's where we should begin.
Great. Thanks, Kevin. We appreciate that. And thank you to our wonderful acequia commissioners and to all of you out there who are engaged in your watershed. We've invited these fine gentlemen to join us to sort of model how we're doing this conversation, because as we said, it starts with the listening. And so we're going to ask these guys, and if you each want to introduce yourselves when you talk, what ditch you're with and what your name is. But we're going to start with a question of what is it that you value? You know, what's so beautiful and working for you right now, and what is your vision for the future? And if it's okay, we can just start and go down the line. That makes you first, Doug. No pressure.
Okay. All right. My name is Doug Dykeman, and I'm with the North Farmington Ditch. The North Farmington Ditch is an urban ditch. It used to serve hundreds, if not thousands of acres of orchard in Farmington. All those orchards are gone, except for small areas. So the North Farmington Ditch has been converted from something that used to be largely agricultural to something that deals with small gardens, irrigation of people's property through town and things like that. So that presents for us a whole significant amount of problems. So what we value in that is that the Farmington Ditch, North Farmington Ditch, is actually keeping a greenway through the city of Farmington. A greenway that wouldn't be there, it would be simply brown through that area. It's approximately 7 miles or so, and people enjoy that for their everyday living and that kind of a thing. We still do have a few farmers on there. I farm on there, and there's several other folks that do. But to a large degree, the purpose of the North Farmington Ditch has changed dramatically.
Thanks, Doug. You off? Perfect. Yeah, pull that mic down so we hear you.
Can you guys hear me?
Yeah.
My kids always said I talk loud, so I probably don't need this. Martin Nee, I'm chairman of Lower Animas Community Ditch. A little background on our ditch: we run about 16 miles from just south of Cedar Hill over to Flora Vista. We run right through the center of the city of Aztec. I know there's a lot of people that don't really have a ditch background here, so let me explain what we do. And this is all pretty new to me too. I've been using the ditches for a lot of years, but I didn't really understand the workings. So when the ditch is dry in the fall, we have to mow 16 miles of ditch line. And it cuts through a lot of personal property right away. You know, there's a lot of Navajo willows, there's a lot of growth along those ditches that we have to get out of there just to be able to access the ditch so people can use their water and stuff. Then once we mowed the ditch, we have to clean it out. There's a lot of silt load that ends up in our ditch over the irrigation season, so that silt has to come out. So we have what they call a clamshell bucket on a little traco, and we go along the length of the whole ditch where we can get in, and we clean out the silt and stack it on the side of the ditch. It's used for ditch bank reinforcement. Then come the spring, when we start irrigating, late April, early April, sometimes we've done all our repairs on our head gates and our sluices. We have sluices where we can dump our ditch to the arroyos in case of an emergency, and we'll start at our diversion and we'll start letting water in. And the ditch still has a lot of debris in it and trash in it, so we'll run our ditch as full as we can to the first sluice, we call it, and we have screens at these sluices. There's probably about 8 or 10 of them along the ditch that the screens will stop big debris from going down the ditch that would plug our culverts and really cause havoc down the road. But so we'll clean the ditch out for a few days at each sluice. I mean, we're dumping silt, we're dumping trash, and it's amazing how much trash is in the ditch. People throw their household trash, their sagebrush and tumbleweeds, everything that blows into the ditch, and then people throw their cuttings in there. We can pull dead animals out, we can pull all kinds of stuff out of the ditch. So what we can pull out, we do, but the silt and everything gets, when we first start flowing the ditch at pretty high velocity, it goes right down those sluices. So we clean the screens and clean the sluices, and we finally get water to the end of the ditch. And our main objective is to keep that ditch full for our irrigators. That's what it's all about. Making sure everybody who's paying to use the ditch, that's our job, is to supply water to the irrigators. People who have water rights and are assigned our ditch, and we need to get them water. So we can regulate, our ditch doesn't have a real high slope, so the water doesn't typically move that fast. We diverted probably about 56 cubic feet per second right now from the Animas. That's the last time I looked. We could pick up that data live from the USGS gauge stations, and we have a Facebook page where I think there's some links to those places too. So, but it's a challenge because, everybody tries to cut hay at the same time, so everybody shuts off on the ditch. All of a sudden, our ditch is bank full and running over, so we have to start sluicing. And it takes a week from a change at the diversion to make it to the end of our ditch. So, it's a challenge. We have a full-time paid position ditch rider that does the mowing, does the cleaning, and cleans out our screens every day, and tries to help us regulate our flow. Not to mention taking calls from people who aren't getting enough water or getting too much water, or, hey buddy, your ditch is overflowing here, So, and then we have maintenance issues. We have some old lined concrete sections of ditch that were lined. Our ditch is over 150 years old, our water rights, and it's been flowing that long. And we have some lined concrete sections that was lined in the 70s, real thin concrete that's breaking up, and it flows through cobble and stuff, so it's leaking a lot. It's leaking a lot in a few places that we have to fix, and that's very expensive and time consuming. So that's a little bit about how we operate our ditch. Some of my likes, I like the culture and the people, I retired a few years ago into volunteerism, right? So everything's above my pay grade. Everything I've heard today is above my pay grade. So all this stuff is above my pay grade. So, but I like the people and I like the water. Things I don't like is the trash in the ditch, the waste. The trees concern me, those trees that just suck up that water, the Siberian elms, the Russian olives, the salt cedars, tamaracks, is that another word for them? And some others that I have never heard about. So that's a challenge. One of the other challenges that, it's neither here nor there with this group here, but, people owe us $58,000. that haven't paid their ditch assessments. And we can't do anything about that except file a lien, which, the lien system in New Mexico doesn't work. And realtors ignore it, homeowners ignore it, and the courts ignore it. You have to refile them every year, and it costs us $50, $60 plus man hours to refile a lien. So we turn people into collections, and they don't care. So, we'd sure like to have that money, but like I said, that's neither here nor there. The other thing that, like I mentioned earlier, there's a lot of water leakage out of our ditch. And I know there's a lot of people who use more water than they have the right to use. We don't have any policing authority on our ditch, none at all, zero. So, if somebody's running a 6-inch pipe, full open to irrigate 5 acres and it's all going back to the river as tailwater, that's making it tough for us to manage. Granted, a lot of that, it's all in the water cycle, it's going back to the river, and it's infiltrating and helping out the regional aquifers, but it makes it tough as a ditch operator to run, so. You've heard enough from me.
Thanks, Martin.
My name's Alan Walraven. I'm with Farmers Mutual Community Ditch. Our ditch starts right below the sewer plant here in Farmington, runs 21 miles to my house. I'm not too smart. Nobody buys a farm at the end of a ditch. That's one reason I got on this board, was to make sure that we could get water not only to me, but several people just east of me. Our biggest challenge is getting water down the ditch. We've been working on 3 water projects. I don't know if we'll ever get any of them done, to be honest with you. Our main project was a piping project. I don't know if our ditch goes underneath the bluff right there at the La Plata Highway, and it covers about 4,400 feet, and then it moves away from the bluff for about a half a mile, and then moves again the bluff. There's several sections in there that on phase 2, which is the second section of it, that you have the bluff, 150, 200 foot bluff, the ditch immediately at the bottom, a 3-foot bank, a 40-foot drop to the river. We spend average about $70,000 a year just taking rocks out of the ditch and rock slides. We've spent as much as $250,000 one year getting the rocks out of there and redoing the ditch bank. We've currently got a project going with the Army Corps of Engineers and the state through some state infrastructure money. This project started 5 years ago, November 10th. Maybe, and I say maybe, they will start construction this October. I don't know. It seems one of the biggest problems I think and challenges of small ditches have is funding and being able to use that funds. We've tried a couple other projects. We've tried a little piping project, 4-foot pipe, about 1,700 feet through the USDA, Interstate Streams Commission. We've got a little money from infrastructure money. The project is going to cost, because of all the government requirements, is going to run about $770,000. So far, we've got available money to use on it about $300,000. So these projects are really tough. Back to the Army Corps one, with that, it's a 6-foot pipe. Our ditch runs from 95 to 105 CFS. That 6-foot pipe, they have spent $1.2 million of our money. And that's a 75-25% cost share project. So of the $4 million we have acquired from the state in our funds, and we put a special assessment on our people on the ditch, $25 a share. which gathers about $100,000 a year, about $105,000 a year, to go just for piping that ditch. Or we wouldn't have been able to even start the project. I know a lot of these small ditches, one of the biggest things that they need to do and haven't done is they need to get a set of bylaws and get a set of updated bylaws. We did that several years ago with Ian Reiki with the State of Saki Association. He helped us write a good set of bylaws so we could control the water in our ditch and control who can and cannot use it, basically. Part of what we put in the bylaws is you can transfer water from your place up and down our ditch, but you cannot transfer the water out of our ditch. We supply water to Lower Valley Water Users Association, which also supplies Upper La Plata water users. We supply water for the golf course, M&I water for them. We've got 600 people on our list. Of that, probably 80 are actual farmers. Most of all that land has been subdivided into 1 and 2 acre lots. And again, the biggest problem we have is collection money from people. I'm not going to use the water, so I don't have to pay for it. And then you've got people that don't understand that an irrigation ditch runs through their property. They've got to allow the people to go in there and clean that ditch, or they have to clean it. Education is really a hard problem. One thing I'm going to get off base here a little bit is I'm glad to see some younger people here. I'm worried about farming as an overall deal. Most people don't want to put the hard work into farm or the time. I just farm a small farm, 60 acres. I work a full-time job. I've got another job, part-time job that I do on top of that, plus farm. My wife calls me a workaholic because I get up at 5 o'clock in the morning and don't go to bed till 10 o'clock at night during the summer. But agriculture is really the lifeblood of the community and this world. And somehow we got to get people interested, and young people dedicated to working in the agricultural fields. And I don't know how to do that, but I hope it comes about. Any other questions? I think somebody else ought to talk.
Church of Mark. All right, thank you. Thank you. My name is Mark Luco. I'm a commissioner on the Elledge Ditch. The Elledge Ditch is small in comparison to my predecessors. We've had 2 surveys done. One was 8 miles and one was 13 miles. Both professional surveys. I don't know which one is correct. I've paced it several times. I just kept losing count. We have about 220 properties that we service. One of the problems that we have is that because of and we service both agriculture and housing subdivision where we've had infrastructure that's been put in. One of the problems that we have that is difficult to overcome is as properties have been subdivided, some of them did not retain the adjudicated water rights. So the laws in statute apply to adjudicated water owners that own the property, not somebody that has been separated from the water. So that's where we end up with a lot. Trash was brought up earlier. And by the way, I won't cover everything because Martin pretty much nailed a bunch of it. Well done, sir. Yes. But the trash is dumped by people that have no knowledge or interest in the ditch. And I think that this is an issue of communicating with the public and the local community. I think it's the general consensus, well, if I throw that branch in the ditch, it's gone, it'll just go down to the river and it's no big deal. They don't realize that, half a mile down, there's a screen that catches every stick and every leaf that's dumped in the ditch. Mm-hmm. So a lot of that is just informing the public and letting people know. The other thing that is a problem is informing the entities that we have to work with. When I became a commissioner in 2018, our ditch was paying gross receipts tax. I know Serafina's already on it, but you know, prior commissioners had a hearing with taxation and revenue and lost the hearing in, I think it was 2005. My wife is a CPA, and so she took them on. And honestly, it was really unfortunate. She ended up educating people at that office. And I'm not trying to be pointing but my concern is that there's a lot of education that needs to take place, not only with the community, but also with these different entities. I think oftentimes, and I don't know how other ditches run their organization, but we're not a business. We're not a, and this is, we had Elledge Ditch Company on our checkbook, and I finally got that fixed so it doesn't say company. We're a group of 220 property owners that have joined together that pay a minimal amount of money in assessments with the idea that we all work together as neighbors, pitch in work when we need to. If there's extra money that's needed, then the members have been really good about saying, well, we don't like it, but raise the assessments. We know it has to be done. Nobody likes to do that, but they're good about doing it. How many people, I don't even want you to raise hands because I really don't want to know, it'll hurt my feelings, but how many people are being compensated for their time today? Because I can tell you the people that aren't being compensated are sitting in front of you. We do all this for free. I was talking to another commissioner who's not sitting up here, but he said, I think 70 hours a month that he volunteers. And that's what we all do. And we do it for the love of the community. We do it for the love of the water. And the problems that we field from phone calls and emails, they're beyond belief. Some of them, it is pretty amazing. Budgetary stuff is always a problem. Our ditch runs less than 50,000. It's right at 40 this year. We're a little bit hindered by raising assessments more because if we raise assessments and pop $50,000 and a penny, then we have to do a full audit. Well, then you raise assessments by an extra $10,000 because that's what it costs for the audit. I mean, there's little things in there that are built in that cause us a lot of grief with our budgets.
And they have to be done every year.
And they have to be done every year. If we stay under 50,000, ditches that are small enough like ours that they're under 50,000, we're not even required to do a tax return. It's not even required. That we had to convince the state of as well.
You said
we're part of this state government.
Yep, local political subdivision.
Serafina said it earlier. I'll finish up and then I'll give up the floor. Political subdivision. That means that we are the same, and this is funny. I tell people we are exactly the same type of organization as the city of Farmington or San Juan County, just with a much smaller budget and no ability to tax. We do assessments. Once a year, one payment, and we're done. Thank you.
Well, thank you guys. I really appreciate your insights and all the hard work. It takes a lot of hard work to keep a ditch running, and part of what we're looking at is how do we continue to do that as the prediction is even less water? Because as you said, your job is to get the water to irrigators so that that's your job. That's the bottom line. And that's actually in state statute. To equitably distribute the water is the mayordomo or ditch rider's job per state statute. These guys are all dictated by state statute as volunteers, nonetheless. It really is a labor of love to also subject them to having to sit in front of everyone, too. It's really nice of them to agree to. But
Free lunch.
Yeah, I said free lunch, and by the way, I kind of, tried to be useful the last 5 or so years. So that's all I want. Just hang out for an hour or so, guys. Anyhow, I really appreciate all those insights. And you started to speak to some of the solutions, but as we try and think big about what will it take for ditches in this basin to persist through drought conditions. He's queued up, he's ready to go. What are some, and it could be we don't know how to get there yet, but what needs to happen, do you think, so that we still have ditches running with water, even if it looks different than it is today, but we still are distributing water in the next 20, 30, 40 years down the line? Whether you're here or not, wink, wink, what do you think it will take to be there?
Well, I think to maximize the water use on the ditches, because everybody likes to eat, the infrastructure needs to be invested in the ditches so they are efficient, so that from head gate to tail end, the water moves through and is placed where it is supposed to be going. And I know that the groundwater is an important source, but when you have irrigation that's taking place, you have that being recharged. But what we have, and cleaning the ditch, I wouldn't even guess how many trees and unwanted, undesirable plants that are soaking up water, and we can stop that if we pipe the ditches. I mean, seriously, when there's no water coming from the ditch, the things don't grow there. And I know that impacts how the community looks, but you want to get the water where you need it.
We'll go this way. We'll start from Martin and
the
then go
other
this
thing
way.
that I'll throw out, and this was something I really thought was funny, when I became a commissioner in 2018, one of the members, and as it turned out, he was a predecessor commissioner, but he didn't tell me that at the time. He said, "How many head gates are on there?" And it was my first day on the job. I said, "Shoot, I don't have any idea." Well, then I found out he was a prior commissioner. He didn't know either. So I took the time to, it took me 2 weeks, to go down the ditch, and this was with permission of the membership. They're real supportive. Went down the ditch and tagged every head gate. We have, I think, 55. My mayor domo's here, he could confirm that. But anyway, because what I could see was we were having shortages of water, and I needed to know where every leak, every potential leak was going to be at, so that if we had to do water rotation, we would be able to make that happen. And I also thought initially that we would be able to, with a mayordomo, enforce people using that weren't supposed to, but we need the Asaki Association to come up and educate our judges.
That's a
Please.
Deep insight. And sheriffs often. Yeah. You want to?
Anyway, this is a meeting I needed to come to.
Yay!
I am also a volunteer retired doctor of education, but got interested in water. And the answers to, Martin, your question, go to the New Mexico Rural Water Association. There's a guy down there in Albuquerque that turns off the water for the people that won't pay their bill. So find out about that. And
there's a lot out there that I have no idea exists.
Yeah, call them and get a hold of them. The next thing, I don't even understand your problem of overfull of ditches. I'm on the lead of the Hammond Conservancy District, and they put block head gates. You know, a chain can go about that much or so. When we get too good, to give them more water. I'm an alfalfa hay farmer on the West Hammond, the only one that has a pivot sprinkler. And the reason we put that in is to save water, because it does. So then, now there's two different kinds of water in this world. I started studying this when I retired because I got mad. And I served with Kevin Lombard on his commission, and he teaches me stuff. And then by golly, I go and check it out and make sure they do it. So I started studying water because I wanted to get some taps. I'm going to die before too long, and my daughters and my sons-in-law and I are the only farmers. You know, you can't hire anybody. They won't come back the second day.
Won't finish the first day.
Yesterday, I'm going to go home and tell my kids, oh, hush up. You know, we don't have any problems at all compared to what you all have. I mean, we know how much water we get. We know how much we use. We know everybody up and down. Know all the people. Speaking of people, I thought I could go down and say, I need some more water taps. And they told me there's no more water. Now, this is drinking water. And that's the difference. I decided, damn it, once in a while I get this way. My husband started that system with 4 other men. I'm going to run for the board. I did. I'm on the board, and by God, it straightened out. Not because of me, but because of everybody working together. Now, what happened? I thought I could go down to my irrigation water and say, I need a few more water rights transferred over to drinking. Oh, wrong. Can't do that. So that's when I started studying. Little things. Kevin's group is wonderful. I've been serving with them 35 years, I think, Kevin. You're a newbie to me. But he helps me, and they help me. My daughter yesterday was talking to Gopi, I think is his name, and we're figuring out the most efficient way to water. All of my kids, all of my sons-in-law, I had 2 engineers, a doctor, master's degree education, figuring out the pump yesterday. You know, I mean, you just have to do it. And you've got it. It's a love. Because I get paid nothing for anything I do. West Hammond water system, now we've turned into Lee Hammond because we merged, because we have a water treatment plant. They won a federal suit for not paying taxes. So my compliments to you all. You know, we're a service to the community, and all over the United States tapped in to that settlement. So I don't know, I think sometimes I'm a crazy lady because I care so much about water. But you remember a guy from New Mexico State University, this is 50 years ago, and he was at a water meeting that I was attending, and he gave a talk. He said, water will become more valuable than gasoline. Guess what? It is. When you go and buy, you know, $1.69, a little thing, add that up, you know, the big gasoline. So there's solutions to many things that you've been talking about. And just go out there and find out. Aaron Chavez took me, or asked me, to be that little video that you all saw yesterday about San Juan County. I went with him to a Colorado River Water Users Association, and they're very inclusive. And I find out things from people that know. He's the president of that organization this year. I wrote a book on this because I got my total knee replacement in COVID, and my husband, I read the minutes of the organization that he started. It's called Water, Water Everywhere, Not a Drop to Drink. Now, a new one that I'm on to now, and you all mentioned it, when we moved out on the West Hammond, there were 12 families. That's all. 12 families. If you drive down there now, you know, I know our water system, but it does combine the north side too, has 8,000 users. We used to have 12. But the water has not been kept up on the adjudication. They're not farming. There's houses and roads and, you know, so it needs to be redone, but I'm a little bit afraid to push that.
Yeah.
Because right now, we farm our entire farm. And if I push it, they may decide we don't need the water we have. But the return flow, they never credit you with. You when you go for needing grants or whatever, by the way, grants drive me crazy. My daughter and I worked so hard to get a grant for the healthy soils, to turn the tillage after we cut back in and keep our sandy soil healthier. We got the grant! We were so excited! And then they said we couldn't cut we used triticated. Well, I don't know about you, but it's $8 difference between a bale of triticated and a bale of alfalfa. 10,000 bales. I'm not going to lose 40,000 if we were doing half the farm. So we told them, never mind. They wanted us to turn the whole thing back in there, not to cut any of it or sell any of it. So I don't know, I think groups like this with farmers and ranchers, we ranched in Corona. Ranching goes like this, farming goes like this, on your income. But it takes your total focus and your total energy.
Thank you. Really appreciate those insights. That's a lot of dedication and the connection that so many across the state. You see acequia leaders also being leaders on the boards of mutual domestic associations, because that's very premise that we talked about, that yes, we want agriculture, we want acequias thriving, but we're community members. At the end of the day, we're raising families, living our lives, and we need water for drinking, water for eating, water for mutual domestics, municipalities, all of those go together. So I appreciate your leadership, and I want to make sure you guys can talk, but I saw you raised your hand, and I want to...
I just wanted to know, you spoke of, in the beginning, you spoke about engaging with tribal communities, but you haven't spoken about what's actually being done, or you don't have representatives from the tribal communities to speak to their perspective and how they're collaborating. So I'm curious to know what type of efforts are being done, what's that side of the story. We see I see that missing piece in the presentation today.
I really appreciate that. Thank you for sharing that question. So from the New Mexico Acequia Association perspective, I'd say we're sort of starting with what we know and the communities we represent, because that's our starting place. As acequias across the state, like where I live in Tewa land, like that's the ancestral lands that I'm living on. And I'm in an active adjudication with 2 different tribes, and I'm on the board. We're doing that adjudication. So we're intrinsically linked and having conversations on a regular basis, and I don't want to get in the mix of it, trying to have them not through lawyers, but through people, because it's a whole different conversation as community members. But I would say this is our initial foray into this conversation, is leading with the communities that the organization I work for represents, which can include tribal members who live on acequias, but it's from the acequia as a political subdivision lens. And then all the other stakeholders are going to build out that conversation. So this is like the first step. Like this is like literally the first thing we've done. And so we're just starting with, this is the acequia experience, because that's the lens we're looking at it through, but that all water users and honoring the tribal needs and relationships are part of that. Honoring the municipal, but there's no municipal representatives up here either, because our start is with our mission and where we come from. And what we want all the water users, we imagine we're all doing independent work and it all needs to keep linking up. So thank you for asking that. Is there anything you wanted to add to that, Connie?
I think you explained it well, but just that the working groups that we're talking about building, that's which we haven't done as of yet. That is where we have a larger outreach. And so far we have a pretty comprehensive list, but our first step is to make sure that that list is comprehensive and diverse enough. So we'll be reaching out to many of you to ask for your suggestions for who else should be invited to that working group.
That's an important point. I want to kind of note 2 things. We started late, and I feel like we should end by 12:30 to make sure everyone gets time to have lunch, because I don't get in the way of lunch, really. I mean, for a little bit, but not long. That doesn't go well. So I want to make sure we get lunch, and I'm really glad there's questions, and maybe we'll take one more question, then if you guys have any other comments you want to share, and And we're gonna have more dialogue after this. We're gonna stay and keep talking about these things. So don't feel like you have to get it all out. Anyone who's not going on the field trip, we encourage you to do that if that's what you're signed up to do. But if you're not, please stay and continue this conversation. So you have your hand up right there.
I do, and this gentleman, veteran. Go ahead. Only take a minute. Out of all of us, how many utilize asset management plans? Anybody? That's the trouble I had when I was an employee here. I go to college, I learn. That's not the way we do it. Asset management, please look into it. If you got to replace a pipeline, you know how much, very close, what it will cost. So, thank you, sir. Thank you all.
Thank you.
One way you can save water is know what kind of soil you're farming. Soil surveys have all been done. They have to do them. If you're row irrigating borders, now that water leaves that pipe, time it gets to the field, shut it off. It's done. But you have to know what that soil will take. If you're sprinkling, that's a different thing. And I don't understand your areas. Like, if you're going to tow to Luna County, they're all wells. The water table's already dropped years ago. Versus the Rio Grande area. And we have over here to which is correct.
It is, that's right, and we want to keep those water tables from dropping long-term, because one of the trends we've seen in agriculture, when water becomes uncertain, people rely more and more on wells, and then you keep dropping the water table instead of having recharge from the acequias moving through the land. And
get water out of the members, that's where the water table over the cities built up, flooded them over. And it's overdrive.
Well, I want to just return to you guys. Do you have any, either closing thoughts you want to share after kind of hearing each other and reflecting back on what's standing out to you, or the major questions you're remaining with, or just what do you think those big picture, big idea solutions are so that we keep water in our ditches for the decades, etc., to come? So, Alan, I'll start with you. We'll move this way.
Well, it's really hard to say. We're trying to pipe as much of the ditch as we can. A lot of our ditch had concrete in it. It was put in the 60s, early 70s. It's no longer there. We instrumented about 5 years ago. We started spraying our ditch banks early in the spring and late in the fall after the water's out, trying to get rid of the tamaracks and trees. We spend probably a month chainsawing and chopping up trees, getting them off the ditch banks. These are all big problems on the ditch. He's talking about 58. We've got 133 head gates, because mine's 133. And we got about 25 pumps in our ditch. So people look at the ditch up in the Kirtland area and they think, oh, man, there's a lot of water in the ditch. By the time it gets to my house, there's none. It's a big problem. We started a program where we color-coded every head gate, and we put a number on them. And this actually started this week, because usually about mid-June, we start running short of water at the end of the ditch. This morning, I had 3 inches of water in my ditch. And my hayfields are really dry. But what we do is we shut it off. Like this week, it's a blue head gate. If your head gate's painted blue, you're supposed to be off for this week. And then next week will be yellow, and the next week is red. And we rotate it that way through the summer to make sure everybody gets water, some water, and they know that they're going to be off, so they better get it irrigated that week before they're off. That way everybody has water for 2 weeks and is off 1. It seems to work real good. The problem we have is new people coming into the community. they don't even know where the head gate is. They just think they go over to their little valve and open it up and they got water. They don't even know what color or what number their head gate's on. We're working through a lot of that, but I think, like Mark said, the biggest thing we need to do is get our ditches piped. Once it's in pipe, you're not losing it through evaporation, you're not losing it through groundwater. I'm thankful we've got a group of men that come into our community that grew up here, have leased up almost all the land down through the Kirtland area, Fruitland, all the way down into water flow, and are planting corn. They've got a project going where they're raising the Wagyu cattle and feeding them. And so a lot of farms that weren't farmed for years are now being farmed. But then again, that creates one more problem, getting water to the end of the ditch. But I think they're doing it pretty conservatively. They seem like they're really watching and taking care of the water, which is a good thing. So, but I think finding infrastructure money or funds to be able to pipe these ditches, it's not cheap. Like I said, to go 1,700 feet, we're looking at $700,000. And there's only 5 head gates in there, so it's not, that area doesn't have a lot of head gates, but it does have a lot of rock and sand in the bottom of the ditch where water is leaching out pretty fast.
So, I guess just talking with water users on our ditch, their biggest concern is probably losing water to compacts and through litigation. People taking our water away, and that's been a fear in the basin for a long time. And I hear it all the time. I can't argue one way or the other whether it's a founded fear or not, you know. But I'll just throw that out there because that is a fear. So, you know, and public education could help that. You know, if there is no fear there, let the people know. Otherwise, they're just going to keep believing there is. And, you know, you've heard here several times, my biggest frustration is money. We can't ask the water users to fund all of our infrastructure. That means we're dependent on the state. We're a state agency. And really, it's tough to get money. The bureaucracy, the details, and God bless Serafina for helping us out, because I mean, she does a tremendous job. I asked her if she'd come and work for the ditches and be a consultant and leave the state, just because she knows the bureaucracy and she knows how to work it. And she's an angel in my view. So, thank you.
Thank you.
And I've seen Serafina with a shovel in her hand too. Hey. So yeah, she knows how to do that. I think the biggest concern that I have is the business of the water rights being moved around and shifted to different agencies, different entities, taken away from the ditches legally, so to speak. The amount of water that's in the mountains is going to determine how much water is going to be in our ditches. So I'm not so worried about that, but I'm worried about the agencies that are attempting to take that water and use it for something else. One of the things that we can do, however, immediately is to fix our ditches. The ditch that I work on has been neglected for maybe 30 years. And we're just starting to get active about fixing our gates, fixing our leaks. By the way, our ditch is the one that floods downtown Farmington. So we do have a problem with floods sometimes. We believe that last year we found the solution to that. So hopefully we're not flooding the downtown anymore. I think that the other problem is getting money that is applied to ditches, to water in general. And that is an area that we probably ought to address. We can depend on the help that we get from the Aseki Association, but it might not be a bad idea if we had some kind of legal entity that takes care of the ditches, so that we don't, each ditch does not individually have to deal with the bureaucracy. An association that legally can handle our issues as relates to the legal issues of who gets the water, but also as legal issues in terms of who can apply for the money and how is the money distributed. So if it might be a worthwhile type of thing to try to get involved, get as many ditches as possible involved in supporting a single agency that has a staff that can handle those things, while we can then focus on getting water through the ditches. So that's about what I have to say.
Thank you. Thank you to all of you. One of the things I say a lot of times is none of us, I do this because I like to grow food, because I like to eat food, which is why we're gonna have lunch soon. Not the reason why, but we're going there. But that none of us really signed up for all this bureaucracy. But we want to get the water, and we want to grow food, and yet there's a lot to manage in the interim to get to that point. So I want to thank all of you for sharing your insights on where the challenges are, what's working. There are fields that are producing food and fodder, and that's beautiful. And I don't know if everyone saw the picture I had up earlier, but I took the picture of, I don't know if it's your ditch, Doug, but there was milkweed growing along a acequia right behind the Comfort Suites this morning, and I was excited. Look, it proves my point. Look at this unlined ditch growing a native species pollinator habitat. Way to go, guys. So there's a lot to digest, from the management to the water availability and the components of humans and nature that are intersecting here, and then so many other entities that aren't at the table. This is just sort of the introduction to some of the issues acequias are holding and what we're hoping to do and transition to. Take a few minutes to eat lunch, and those of you who can stay, everyone would like to hear what your perspective is. What are the challenges your community or the water users you represent face? What's your vision for the future? What are the big picture idea solutions? What changes need to happen so that we can have a healthy regional water system? So just, again, thank all of you for the wonderful work you're doing to protect our sacred waters in whatever capacity that is, and especially to our acequia leaders who made it out today and our panelists. Thank you so much. We look forward to continuing the conversation.